Welcome to the Audrow Nash podcast. I'm your host, Audrow Nash, and today we're diving into a fascinating world of AI-powered food automation with Rajat Bhageria, the founder and CEO of Chef Robotics. In this episode, we explore how Chef Robotics is revolutionizing the food industry by developing AI-enabled robots for food assembly. Rajat shares insights on why the food industry is arguably the best market for AI today, discussing the massive labor shortages, challenging work environment, and the potential of AI to transform food production at scale. You'll learn about Chef Robotics' journey from concept to production, including their strategic approach to market entry, data collection, and scaling their technology. Rajat offers valuable lessons for aspiring roboticists and investors, covering topics like the importance of real-world training data in robotics, how to bootstrap a robotics startup and secure customer commitments, the challenges of deploying robots in production environments, and the future of food automation and its potential impact on the industry. Whether you're a roboticist, an investor, or simply curious about the future of food production, this episode offers a wealth of insights into one of the most promising applications of AI and robotics today. So grab a snack, maybe one assembled by a robot in the near future, and join us for a fascinating exploration of AI, robotics, and the future of food. Let's dive in. Would you introduce yourself?
Hey, Audrow. Yeah, I'm Rajat. I'm the founder and CEO of Chef Robotics.
Awesome. And would you tell me some of the details about Chef Robotics, like how many employees you are, what stage of funding, these kinds of things?
Yeah, so Chef Robotics, we're like 32, 33 employees. We're based out of San Francisco, California. Funding wise, I think we're at 22.5 million in equity and debt. I think 18 or so of that is equity. And the rest we use for equipment financing to fund the robotics-as-a-service. Um, we have robots actually now deployed all over North America, including Canada. We're actually now actively thinking about Europe as the next kind of
Wow.
market. Yeah. And things are going relatively well. So we've now actually made around 17.7, I believe, is the latest million meals in production, which is awesome. So that's broadly what we do. And of course, we make AI-enabled robots for the food industry. And of course, there's a lot more depth there, but
Mm-hmm.
broadly, AI-enabled robots for the food industry.
Hell yeah. Now, when we talked in a quick call before this interview, you gave me an overview. How did you pick this market, and then kind of how you started Chef Robotics, and how, I don't know, the whole problem space that you're going into. Would you tell me some of that start at the motivation or the market?
Yeah, sure. So, in college, actually, so I went to Penn for undergrad and grad school. I was working on a company called Third Eye. We were using computer vision to essentially recognize what's in front of you for the visually impaired. And worked on this company for 3.5 years. And we can talk about Third Eye as well if you're curious. But
Sure.
I think this company really introduced me to the power of computer vision more than anything else. Before then, like I had done a lot of like web programming and like desktop programs, but for the first time, like a computer can make sense of the physical world, which was just insane to me, right? And it kind of like really got me thinking about like the power of AI and computer vision. And my next kind of question is, okay, well, like Third Eye was completely a software product, right? We were using smart glasses, but of course those are off the shelf, or mobile phones also off the shelf. So it was purely a software product. And I was like, okay, well, is the biggest application of AI, is it going to be purely in the digital world, or is it really going to be in the physical world, right? I was just curious, right? And so I just started to kind of like do some brainstorming. It's like, and it became abundantly obvious. Like the
Mm-hmm.
like 90+% of global GDP is in the physical world, right? It's like things like construction and agriculture and food and beverage and healthcare and all these other industries, right? I mean, these are really where the majority of the wealth of the world is at. So I was like, okay, well, of course, then if you're interacting with the physical world, then you can take sensor data in using a camera, but of course, you also probably need to actuate. So I think I became pretty excited about the prospect of kind of combining AI plus robotics to have embodied AI, right? And this kind of became like extremely, extremely exciting for me because I feel like I'm very lucky to enjoy my work. I really enjoy my work, but I do know there's hundreds of millions of humans, billions of humans who don't have that luxury, and it seems wouldn't it be nice if we lived in a world where there was abundance, where robots can do some of the dull and dangerous and dirty jobs, and robots can do, and humans can do something hopefully more humane and better. So that vision was exciting, and I wanted to really focus on embodied AI, and that's kind of decided to get my master's in that and focus in on that.
Hmm.
But I didn't know what product to build yet or what industry yet to focus on, right? And I took a bit of a detour to kind of figure that out. A friend and I started a small VC fund called Prototype Capital, basically investing in founders who are using new technologies in old industries. Old industries like oil and gas and food and beverage and all the industries I just alluded to, right? Uh, and again, we can also talk about the prototype experience, but at least what's relevant for Chef is that allowed me some time to just kind of understand the industry, the physical world a little bit more, talk to a lot of people in these different industries. What I learned is actually that the food industry is probably one of the best places to apply AI, just from a market size perspective, period. And specifically, the reason I say this is that if you look at the Bureau for Labor Statistics, the domestic population in the U.S., the most common job are things like the number one and number two most common jobs are retail salespeople and nursing aides and personal aides. Um, those two jobs I don't think will be automated by AI robots anytime soon. It's a very human job.
Hmm.
So, okay, it was like, okay, what's number three? Number three is food service and food preparation. So that felt a lot more tractable to me, right? And by the way, I'm not from the food industry, right? So I didn't totally understand it, but I can at least, I go to Chipotle and Sweetgreen, and I've seen those people assemble those meals. It seems like you could take a camera and a manipulator and some different utensils and make a robot that does that too. So it just felt a little bit more tractable to me. So that idea of, okay, like it seems like the market size is pretty big, was exciting. And specifically, like there's an interesting insight, which is like if you agree that the biggest impact for AI is in the physical world, because 90% of global GDP is in the physical world, then it's like, okay, well, what part of the physical world do we focus on? And then we said, okay, what's the biggest market in the physical world? And it's a labor market,
Hmm.
which is like $45 trillion of GDP. And then, okay, what's the biggest part of the labor market? Well, it's retail salespeople and nursing, but that's not tractable. So the
Hmm.
biggest tractable market for AI today, from this like an analysis I did at least, was food service and food production, food preparation. So it's like, okay, there seems like just from a market size perspective, this is something that I want to like really investigate and look into. But of course, like I said, I didn't know much about the food industry. So the
Hmm.
next step was just talking to as many people as I could possibly talk to. Um, and, I think this was a very broad search, right? This was everything from fast casual operators to ghost kitchens. At the time, Travis Kalanick had just raised a bunch of money for cloud kitchens.
Hmm.
Um, and companies like Reef and Kitchen United were kind of blossoming. This is still pre-COVID, by the way. We talked to like food truck operators, we talked to airline catering companies, food manufacturing companies. What's the biggest pain point you face, right? What's going on, right? And what I learned is that the biggest thing that everyone said over and over, without exception, was there's a really, really crushing labor shortage.
Hmm.
And of course, in robotics, you hear this very frequently. It's not a new piece of information. What was interesting with the food industry, they said, is that oftentimes food environments are extremely cold, 34, 35 degrees Fahrenheit, or extremely hot, right? 80 plus, 90 plus degrees
Hmm.
Fahrenheit. So hiring is actually oftentimes harder than other industries like warehousing and logistics and supply chain.
Hmm.
So it seems like there was a very pressing need where AI plus robots could really help, right?
And you're saying
And
that
what was interesting,
the reason that, or one of the reasons that the hiring is difficult is because of the environmental conditions, that it's hot or cold. So it's unpleasant to work there, and thus people don't work there often. And I saw like the turnover is super high for the people that are in it. So you think it's like it's miserable,
yeah,
possibly partially because of the environmental conditions, and that just
yes.
exacerbates these labor shortages. Okay.
Yes, and not only that, like, you have these redundant motions, right? I
Hmm.
mean, you're like you're
Chopping or,
often chopping and scooping,
yep.
and you're doing a lot of redundant motions. So you have like back injuries, and
Mm.
there's just a lot. It's a lot of physical exertion in a very uncomfortable environment,
Mm.
which comes together to not be the greatest job,
For
right?
sure.
So I think this obviously has a lot of implications. So for the business itself, I learned, right, and this is again true from the big kind of food manufacturing companies to the small food trucks. The business implications are also severe, which is that they often are leaving revenue on the table. Specifically, what I mean by this is like, if they could have made, X meals or
Oh.
volume,
Mm-hmm.
now because they don't have enough labor, they can only make 70% of X. So they're leaving revenue on the table. Like their supply of labor is not able to meet demand of labor.
That's wild. Okay. Yes. So they literally are just not making as much money as they could if the production was higher
Yes,
for this kind of
that's
thing.
right.
And that probably
Yes,
also drives inflation in their costs and things like this because
yes,
it costs more to get
yes,
out less and then they're making less
yes,
profit and then they have to charge more for
yes,
what they do make. So that's a vicious
yes, yes,
cycle, I think.
yes. And there's another vicious cycle in there as well, which is that because you don't have enough labor, you have to ask your current folks to work overtime, which of
Oh,
course,
increases
it's
turnover.
not like because there's turnover, so
Or
like
but
now
even
you're
increases
I
it
mean,
further because of this.
yes,
They burn out.
yes, yes. They burn out. They burn out. So it's a pretty rough situation. And by the way, that's kind of from the business side. There's another like more like kind of socioeconomic and
Love to hear
nationalistic
it.
reason. Like
Hmm.
some of these companies, especially the bigger ones, the manufacturing ones, right? The food manufacturing companies, they were actively at least considering, hey, how do we make this work? Obviously, robotics is on the table, but also like, can we take at least parts of our supply chain? Maybe not everything because it's food.
Hmm.
There's a freshness factor, but can we take parts of our supply chain offshore? So these are, both these things combined, and it felt like, big market, like arguably number one market for AI, market size, from the market size
Yeah.
perspective. It seems like there's a hair on fire problem, right? And so, okay, I was like, let's dig deeper, right?
What do you mean hair on fire? Like it's a big problem right now. Is that what you mean by that?
What I mean by that is like, I think like in startup world, one of the lessons at least I've learned is that, you can have products that are like, the classic expression that many VCs use is
Like
like
pain or
the
vitamin?
painkiller versus, yeah,
Yeah.
exactly, right? So like, a vitamin, like you can sell it, but it's never priority number one. It's like let's take care of that next quarter, right? Like sales cycles are long and like it
Hmm.
doesn't really have that like exponential growth. Whereas if you have a painkiller, it's like the sales cycles are quick. It's like the Warren Buffett quote: "I want a business that even a dumb person can run." Right? That idea,
Yeah.
right?
It's a great
Um,
quote. Okay.
yes.
All right. So hair on fire.
It's a hair and fire problem, and they really desperately need a solution. Um, another way, like another analogy that's coming to my mind right now is like when like SpaceX was founded, there wasn't really a great launch solution, right? Of course, you had governments; they're expensive, extremely expensive, very
Oh
slow.
yeah.
Um, and SpaceX was able to actually kind of come in and like people were willing to work with them, even though they actually hadn't launched any successful rockets in the early days, because they were the only game in town, right?
Hmm.
So like, because there's a hair and fire problem for people to take satellites to space, um, there wasn't really an alternative. People were willing to like work with a small, scrappy startup and make it work, right? If that makes sense. So there's a lot
Hmm.
of reasons why like that kind of problem is a good problem to solve, I think.
Gotcha. Okay.
Um, so the next question is, okay, great. Like it seems like market's big. There's a big problem that AI and robots can help with. The next kind of question I had is, okay, well, what kind of task do I work on? And again, I'm not from the food universe, so what I did is just interviewed a lot of people, and what I learned is that broad strokes, right, and everything except fine dining, because again, we're not trying to focus on fine dining,
Yeah.
and everything except fine dining, you basically kind of divide the world of a kitchen into like three broad strokes tasks. You have to kind of prep food,
Hmm.
which is kind of cutting things, washing things, kind of getting the ingredients ready. Then you have to do the cooking itself.
Hmm.
And then finally, you have to do the plating or the assembly. Just to kind of put the plating or assembly into context and help you visualize it. Essentially, it's kind of what you would see at Chipotle, right? It's the person who's kind of scooping the chicken, the rice into your burrito or your bowl. Um, but really, the thinking there is like you have to kind of be flexible, do lots of ingredients, deal with the different portion sizes, place in different compartments or parts of the tray or burrito or the wrap or sandwich, things like that, right? Not spill it, not damage ingredient, etc.
Hmm.
What was really interesting for me is that my impression was that cooking is going to be the most expensive part of this process from a labor perspective.
Hmm.
What I learned is that actually that's not true. The most expensive part of this process is food assembly, which is interesting.
Hmm.
And the reason it was interesting is that what I learned is that from a prep perspective, there's actually a lot of traditional automation, essentially food processors, right? Is the way you can think about it. Now they might be, a
Industrial
Sweetgreen might have
scale.
a different.
Hmm.
Yes, no, exactly. But even like food trucks use it, even like fast casuals use it, right?
Wow.
And of course, food manufacturers use it. Different sizes, of course, but
Yeah.
yeah, I think you get that analogy. So, you know, food prep it does require labor, but it's not necessarily something that scales linearly. In other words, if you need more volume of material, you don't need more human beings, right? Because you have this like traditional automation,
It's very
it
efficient.
scales more sublinearly. It's very efficient. It scales sublinearly, right?
It's like one
So
person
okay,
driving a huge tractor or something like that,
that's right.
as opposed to a bunch of
That's
little
right.
tractors. Okay.
That's right. That's right. Um, that same analogy is true in cooking, but for a different reason. So in cooking, you can cook in batches,
Mm-hmm.
right? So, one person can cook a soup for 1,000 people.
Mm.
One person can be at the grill flipping burgers for 60 people, right? So again, same analogy. It scales relatively well. It scales sublinearly,
Mm-hmm.
right? You can imagine that if you're like, at Chipotle during dinner rush in Manhattan, you can have a few cooks, like two, three. They can cook for everyone because you can do big portion
Yep.
sizes, very big batches. So that leads us to assembly. Assembly is the only part of this equation that actually scales more linearly. In other words, if you need more output or you need more throughput, you need more human beings
Mm-hmm.
because it's an assembly line, right? Each person's if you literally need more bowls coming out, you need more humans making those bowls in parallel.
Mm-hmm.
Um, does that kind of make sense?
Yeah, because you're basically. I'm thinking of. I mean, assembly is the good word for it. But like, if you had, I don't know, you're adding a single, and each person may be adding one ingredient in one spot, and it's like that's
Yeah.
pretty. You have to do that manually. You can't do it.
Yeah.
There's not like a big scooper with 100 ends that you can just,
Yes.
especially
That's
for
right.
custom dishes, especially for like restaurants, I would assume at like endpoint locations, like right where the
That's
customer's
right.
eating. But it's probably true elsewhere in like those grocery store buy a meal in a
Yes.
bowl kits and this kind of thing.
That's right. That's right. That's right.
Okay, so
So
that's linear almost. It's probably basically linear in terms
it's
of,
basically linear.
uh-huh.
Yes. So basically, what I learned is that like 60% of the labor in a commercial or industrial kitchen
Mm-hmm.
that makes meals is in food assembly,
Wow.
otherwise known as plating,
That's
right?
bonkers. I would not have thought, but it makes sense now that you're explaining it. But I really would have thought prep would be larger, but I see what you're saying about you get the efficiencies of it. And same with cooking, you
Yes,
can batch. Whereas assembly, you
that's right.
can't batch, and therefore when you're doing scale, that's the one, because it's linear, it's such a problem.
That's right. That's right. So it became pretty clear that if we were to kind of help with this labor shortage, if we were to solve one problem, we should really focus on food assembly,
Mm-hmm.
right? Now it was like, okay, like great. So, we have a big market, it's a big pain point. We think that the biggest thing we can help across the market, not just in like fast casuals, but not just in food trucks, but really across the market, food manufacturing, it's food assembly. Then it was like, okay, like who are going to be our customers, right? Who do we sell to?
Mm-hmm.
And of course, like the first question is this a B2C company or is it a B2B company? Um, we considered B2C actually. Like at the very, very beginning of Chef, I was like, okay, well,
Would
like,
that mean like I
can
buy
we
a
make a robot?
product for my home kind of thing? Like,
So I thought about both. You buy a product for your home, and also you buy the end sandwich or burger or
oh, okay,
coffee, right?
cool.
So, um, the product for your home idea, I didn't.
That one's
I did a
hard
few
and
thought experiments.
expensive. Yeah.
Well, it's hard and expensive, and actually, like I actually did a bit of a thought experiment with my friends. Basically, I posed to them the question: okay, look, like let's say you have two potential options. Option one is like this like black box in your house, and it's gonna like make anything you want. I don't know how it's gonna work yet, but just
Yep.
assume it exists. Would you rather have that, or let's say option B is imagine a future where we have the proliferation of robots that actually make the food, which means your food is like um, much more customizable than it's essentially as customizable as you would have in your house. It's fast. It's probably cheaper,
Oh.
right?
Mm-hmm.
Imagine that these robots are in ghost kitchens,
Yep.
and so what that means is
They
that
just
your
output an
price of
order and it's delivered to you. They handle stocking.
yes,
Okay.
and it's probably cheaper as well.
Yep. Because it's
And finally,
scale. Okay. That sounds great.
because of the scale, and then finally, it's also delivered to you by a robot, so it's cheaper and faster because of that.
Sounds hard.
So
But
but what was interesting is like you can visualize that future,
yep,
right?
totally.
And what was interesting is like every single person said option B, which is to say like they would rather and what I asked about why, and they said, look, like it's because first of all, I don't want to have to take care of a robot. I don't have to refill it.
Mm.
I don't have to clean it. I
Yeah.
don't have to pay for it. I'd rather rent the food, if you will, than buy the food equipment. Um, And plus, I get access to my favorite chefs. I like the brands I like. I don't want to have to give up those brands.
Uh-huh.
And anyways, like this thought experiment was a very quick thought experiment, by the way, but it basically kind of put a big dent in my head about like at-home robots.
Yeah.
Um, I became more and more convinced that
Do
actually
you think
like a
that
lot of the things
generalizes to
I,
other? I suspect how you say it, that it probably does generalize. But
I think it does. I mean, like a good example of this is clothing, by the way. So like back in the day, right? Like people used to make textiles at their house, a cottage industry, right?
yeah.
Right. But then over time, of course, we learned that there's efficiencies of scale, right? Like it's better to have a central factory near the water where you can kind of make all your clothing and
Hmm.
then you can buy the clothing. Um, so I think I think it generally scales. I mean, you can imagine a future where a lot of the day-to-day stuff you do at home, you kind of ship out, just like a ghost kitchen is kind of a central factory, if you will. You ship it out of your home because you have autonomous delivery, right? That's the key assumption here. Autonomous delivery, ship it out to a central location. They do the processing and ship it back to you.
Hmm.
Um, Even clothing, so like in big like factories and industrial settings, like companies like Aramark and Cisco, like they basically like the smocks, like those are actually cleaned in a separate facility, and Aramark delivers them to like your restaurant, your plant every
Yeah.
day. It's already a thing, right? So I think that analogy actually could work. There's
It's a
certain things
cool
that need.
model that's probably up and coming. I'm thinking even like delivery, laundry services kind of thing.
That's right.
Hmm.
That's right. I think there's certain things that just need to stay in the house, like cleaning,
Yeah.
right? Cleaning just it's a fundamental, like which is why like companies like Roomba have actually done well in robotics, right? But anyways, all of that to say that like I was less convinced about like selling robots to consumers. I'm still
Yep.
less. I think robotics is more fundamentally a B2B business. I just think that's what it
I
is.
agree.
Um, unless you're the end consumer, right? So like unless you're Tesla and you're building your own robots, or like Tesla makes their own robots for their own facility, right? But they're also selling to a factory, if you will. So
Hmm.
um,
Still B2B. Yeah.
still B2B. So okay, I said no to selling robots to consumers. Then the other idea was, okay, what if we actually made our own restaurant? Like what created our own spice and everyone else has done. That also, I mean, it didn't really hold water for me, and there's a few reasons for this. I mean, just on the surface, I mean, it felt very much like, and we've all read Zero to One, right? Like, it very much felt like the perfect competitive market that Peter Thiel talked about.
Yep.
Like, it's a little bit better, but it's not that much better. And and another restaurant opens up down the street, and
Yeah. It's
you're
just a
you're
gimmick
out of
to
luck.
me,
It's just
basically.
a gimmick.
Like it's
It's
not,
just a
you're
gimmick.
right. Maybe it's like two times better or something, maybe two
Yes.
times faster or
Yes.
something, but it's not
Yes.
like that
Yes.
much and you have to wait. Probably like
Yes.
lines and all the things to get to it. So it
Yes.
gets half, I don't know,
That's right.
twice as
That's
good,
right.
half as good because of the lines, and then it's
Yes.
about the same.
And by the way, this idea of making your own restaurant, it's built on an interesting foundation. So I actually, again, I interviewed a lot of robotics founders when I was trying to figure out what to do.
Yep.
Like it's built on a really interesting foundation, which is like, look, like trying to deploy robots in other customers' site is really freaking hard. And the
Hmm.
reason it's hard is that every customer does things a little bit differently. There's different ingredients for us in the food industry. There's different pallets in the palletizing industry, etc.
Hmm.
So what if you could just control the environment? You have your own environment. You're your own customer. It's like Nolan Bushnell like selling Atari to Chuck E. Cheese's, which he founded both of them. He built Chuck E. Cheese's and he built Atari to sell to Chuck E. Cheese's.
I didn't know that. That's
It's
so
kind of that
funny.
idea.
Yeah.
So and you constrain the environment. It's like you really
So there is the
you make the
appeal.
technology.
Yeah.
Exactly. The technology problem is a lot easier, right? Which is notable. But the issue I've learned from these same founders is what you called out, which is fair. And there's two others. Number one, even if you get the robots right, oftentimes it's really, really hard to get the food right, right?
Yeah.
Just like for example, like many I won't call out names, but many companies face this, right? They made really cool robots, but then consumers would buy the food, and it was like, fine. But I
Yeah.
actually
Meh.
prefer Domino's. I prefer Domino's. Or I
That's
prefer
funny.
Starbucks. Or I prefer
Whatever else.
whatever else.
Yeah.
And then I also learned that like, you're essentially stacking two businesses on top of each other. So you have a
Exactly.
robotics
That's what I was going to
business,
say.
which is very hard,
Hmm.
and you have a food business.
Yep.
And you're stacking the probabilities.
Totally. Yes, 100%. It's much harder. You have to be two CEOs at once. Um,
Yes.
and I think one of the things also with this is it's a huge upfront investment, kind of because you have to get both businesses going at once.
Yes.
But to me, like, okay, we're going to talk more about what you guys are doing, but like if you guys
Yes.
want to scale to that in the future, you can
Yes.
gradually build up capabilities and
That's right.
so from that, you'll be in a much stronger position to automate the rest of it because you're basically doing one
Yes.
of these problems at
Yes.
a time
Yes.
versus both at one time and requiring a huge capital investment all at once.
Yes.
Uh-huh.
That's right. So, anyways, okay, the question is, okay, who do we sell to,
Yeah,
right?
who?
So, selling the robots to consumers is out.
Uh-huh.
Selling burgers and sandwiches and coffee to consumers is also out.
Yep.
Which, by the way, you've seen this in the industry, right? Like the people who try to build at-home robots, they've all not done well.
Yep.
The people who've tried to sell food, they've also not all done well.
Yep.
Most of them have.
Yeah,
don't
I
exist
literally
anymore.
have not had any on this podcast because I didn't like any of them before this. Yeah.
Yes.
But
Uh, um,
so
so now it's like, okay, B2B.
uh-huh. Great. Okay, so you're B2B. Who do you sell to in B2B or which market segment of the B2B set of companies you could sell
Yes.
to?
Yes. So, well, there's some interesting story there too.
Mm-hmm.
So, when we first started, our natural inclination was to really get on the bandwagon of delivery. So Uber Eats was really kind of picking up steam. This is
What?
again still pre-COVID.
Yeah, actually, can you tell me kind of like the timeline of where we
Yeah.
are when you started this kind of thing? Just
Yeah.
broader
Yeah.
context for this.
So basically, like, kind of started the company kind of like mid 2019, and this is kind of when I was doing all this exploration.
Just
really,
before
right?
COVID. Okay.
Just before COVID, yes. And yeah, so what we were kind of thinking about is, okay, well, delivery is really starting to take off, and this is again from empirical data from the customers. We really tried to talk to the customers early on before we even kind of built anything.
And customers being
Um,
businesses, right?
at the time, it was just food businesses,
Ah, I see.
super broad strokes. Like
Yep.
any food business, let's talk to them.
Hell
right?
yeah.
Fast casual was something that was kind of very obvious. It seemed very obvious to us.
Can you
It's
define
very
fast casual? Like, is that Chipotle?
Yeah, fast casual
or
it's Chipotle basically.
Oh, okay.
Chipotle, Sweet Green, Diggin, Kava, Mixed, Salad and Go, any kind of place where you have the count. It's like the original guys here were like Subway, right? You have the original counter, and you're kind of assembling the meal.
Yep.
Like the ingredients are pre-cut and pre-cooked, and you have a human who's kind of assembling the meal into a sandwich, a burrito, a wrap, whatever, right? And yeah, so what was really interesting here is that delivery was really taking off. Cloud kitchens were really starting to gain steam. And again, this is even pre-COVID, but even pre-COVID, 40%, 30 to 40% of volume was delivery orders, which was very fascinating. So in other words, people were not going into the store and picking up their Chipotle or their Subway or their Dig-In. They were rather getting it delivered to them using one of these aggregators like Uber Eats and stuff.
was
right?
that across the U.S. or in specific locations? Like, I'm wondering where
I'm
your
guessing it was
data.
more of like a coastal.
Yeah, that's
I'm
what I would
guessing it was
guess.
one of the
Like, it seems like
yeah.
in San Francisco, maybe that's the case.
That's right. That's right.
But I don't know, middle of nowhere farm country. I doubt this is the case.
That's right.
Kind of thing.
That's right. And by the way, that changed after COVID, of course.
Yeah.
But before COVID, you are totally right. So, anyways, we like when we first started off, like we kind of really kind of thought about, okay, fast casual seems like a good go to market, right? And we actually kind of and I'm kind of cutting the chase to really answer your question about who we sell to now. But we actually got some early customers, we got some early prototypes. That's kind of how we raised some of the earliest funding we had, and we actually shipped some prototypes. At the time, they were just prototypes to one of our early customers in San Francisco, and we're like, hey, customer. I'm not going to say the customer's name right now, but hey, customer, like, we built a robot that can like flexibly assemble leafy greens for you. Is that useful for you? and what we realize is that in a fast casual environment, right, that is not useful. And the reason it's not useful is, let's talk about an employee who works at a Sweet Green. Let's just say arbitrarily, right? Could be any fast casual chain or ghost kitchen. The volumes are actually relatively low. It's not like you're making tens of thousands of meals. You're making a few hundred meals a day. So What does that mean? What it means is that the jobs are very generalized.
You go down the whole line giving the
You
items,
go down the whole
not
line.
just one specific thing,
That's right.
not just the leafy
So, in other
greens.
words, not just the leafy greens. So, in other words, if we wanted to say, hey, Sally, or the store manager wants to say, hey, Sally, I want you to do this other thing today. We have this robot that's going to do the assembly. Well, for Sally to actually be able to fully leave, our robot needs to do 100
Everything.
ingredients. Everything. And if we cannot do everything, then Sally cannot go do another task. By the way, there's not a labor shortage, so there's no risk of Sally getting laid off. It's just Sally's going to go do something else.
Or you
But
mean
Sally
there is
can't
a
do
labor
that.
shortage, so Sally's not going to get laid off? I
Sorry,
might have heard the exact
there is a labor
opposite.
shortage.
Okay.
There is a labor shortage. Like that. That's what I meant. So, so this was really interesting, right? So what I learned there is that in robotics, to actually be able to add value to a customer, you essentially need to have at least a human equivalent. At least. If you have less than a human equivalent, like it's kind of one or zero, right? If you have less than a human equivalent,
In that specific domain, you're saying, in the domain
that
of fast
specific domain.
casual, this is what you're saying.
yes,
In other areas too?
But I think it's other areas too, right? So like the place where this changes is if you have extremely high volume,
Yep.
right? If you have extremely high
And
volume,
you can production
then
line it.
exactly, each of the roles are more specialized.
Mm-hmm.
But even in that case, you still have to have a human equivalent. It could be any of the humans, but they have to have a human equivalent of the task they're doing, right?
What do you mean human
So-
equivalent? I don't quite understand what that means.
Okay, so like let me kind of paint it this way. Like in fast casual, Sally's got to do 100 ingredients.
Yep.
If we cannot do the 100 ingredients, we don't have a Sally equivalent.
Yep.
In other words, I cannot go to I cannot go to yeah.
Sally equivalent is a very funny way to put it. Okay.
Yes. If I don't have that, then I can't go to this customer and say, hey, you should pay me like you pay Sally, which is a salary,
Yep.
a robotics-as-a-service salary. I can't do that because I haven't kind of
You haven't done the task.
offset Sally so she can do something else. Exactly. Imagine, on the other hand, you have like more high volume production.
Mm-hmm.
In high volume production, if you have somebody on an assembly line, they're doing one task. Now, oftentimes in manufacturing, for example, there's still changeovers. It's not like you're doing that one task 24 hours, or sorry, like 8 hours a day. Maybe you might be doing it for 5 hours and then doing another task for 3 hours. There might be a changeover, but you have a couple tasks, a few tasks, right? So if I can have a system that does a few of those tasks, let's say 5 tasks, or 5 ingredients in this case, because it's food, then I have a Sally equivalent.
In those tasks because
So-
it's high volume. So the distinction
Yes.
here, it's not the fast casual dining, it's the volume. Because with
It's
higher
volume.
volume, you have the ability to do specialization, and this is where
Yes.
robots are beneficial.
That's right. So what we basically realized is, look, like at the time when we were really focusing on fast casual, this is kind of telling you the sequential story. And like, you know, it became it was like an interesting time. It's like, okay, we know this is a big market. It's arguably the biggest market for AI. We know there's a big problem. We know that food assembly is the right thing to solve. We believe we have the right go-to-market, which is selling to other food businesses, as opposed to being the food business itself,
Definitely.
or even selling the robots. We believe that this technology is possible. Like we believe that this all is possible. And further, we even believe we have the right technology architecture, which is more of like a pick and place and AI-based system, which is a lot more flexible than a dispensing hard automation system. So we were a little bit like, we feel like we got all these things right. And yet it's still not there yet because we can't do 100 ingredients. So then we started to ask ourselves, okay, how do we do 100 ingredients? What's the bottleneck, right? What we learned is the bottleneck is very simply just AI training data, which is to say, like, the thing with food is that food is very highly dimensional and it's very long tail. So obviously different ingredients are different than each other. So like a potato mash is very different than diced chicken, and diced chicken is very different than shredded chicken, and shredded chicken is very different than a thin sauce.
Yeah.
So obviously ingredients are different from each other. But the thing is, there's also a lot of differences within the ingredient. So that same diced chicken, it's being cut by a human being. So every single day it's going to be a little bit differently cut. And by the way, it's also being cooked by a human being. So sometimes it's going to be cooked a little bit longer. Sometimes it's going to be cooked a little bit less. Sometimes the cook's going to add a little bit extra oil, which means the stickiness is different. In other words,
Super
it's a very highly
variable.
dimensional space. It's extremely variable. And by the way, this is not even to say anything about the organic structure, but it's an organic material.
Yeah,
So
totally.
even growing it is different. So to deal with this, like AI, we learned is just necessary. And and
Because
so
it's an
okay, so like
edgy
if
problem. Like you spend a lot of time on edge cases, and because of
that's
this,
right,
AI is better than like really hard coded rules,
that's right,
a more
that's right.
classical approach. Okay.
That's right. So that's exactly right. So like maybe another way like to express this is let's say I wanted to make a robot that just does rice, right? It just and it's not even just rice. It does like one particular kind of rice that a machine cooks the rice and even the machine does everything. So you know the input is exactly the same every time. Well, yeah, like I could hard code a system, maybe not hard coded, but I could have like a rules based system,
Yeah,
right? That probably would do fine.
totally.
But now if I want to have a flexible system where like the inputs are variable every time and different customers make their rice differently, and by the way, they don't just have rice, they have trillions of other ingredients.
And also,
Well, it's a little bit harder.
for sure. And but so with the way where you have the exact same rice every single time and it's made by a machine, that requires a lot more investment in infrastructure to have that machine, to transport it, to arrange it the exact same way every time. And
That's
so
right.
that's a bigger expenditure for the customers. And so that would probably limit the market that you could go after for this kind of thing.
Yes.
So having
Yes.
it be flexible makes it so more people can do it. You want to make it so you can try your robot, or like deploy just one of them or something, have it at relatively low cost to the customer. They don't have to change their whole like floor plan or anything. So, I mean, flexible is way better for lots of reasons, I
Yes.
imagine, especially for the customer.
That's 100% true. And actually the industry has a lot of like what's called low mix, right? Automation. Low mix is kind of what you're saying, right? Like you're trying to make a system that does one thing. Like an example from like electronics might be you're trying to make a line that does iPhone 15s. That's all it's going to do.
Yep.
If you try to do max on that line, it's not going to work, right?
Yeah, I think of
So
molding
low mix,
generally for this
yeah,
kind of thing, where it's like
yeah,
you have one mold, that's all it's going to make.
yes,
This kind of thing.
that's
You
all
can
it's
make a
going to make.
bunch of them, but you
Yes,
can't change anything.
yes.
And
That's
so,
right. And the same thing is true in the food industry, by the way.
yep.
So like if I'm like Kraft Heinz, right? Kraft Heinz, for example, makes ketchup. No, if you make ketchup, you don't have 50 kinds of ketchup, right? You have like a few SKUs,
Yeah.
right? So you're going to go to a systems
Super
integrator
low
and
mix and high volume. Yeah.
it's extremely high. Exactly. So you're going to go to a systems integrator. They're going to you're going to pay them 10 million bucks, but they'll make you a system that like perfectly makes those bottles of ketchup for you, given the same inputs, which you can basically guarantee because you have a custom line, right? Um, so we were like, okay, look, like back to kind of the chef world, right? Like we had just done kind of this fast casual experiment. We're like, okay, we got to have 100 ingredients to add value to fast casual. Um, we can't do that right now because we don't have training data for 100 ingredients. Because and by the way, we can talk about that too. Why don't we have training data for 100 ingredients? It's because unlike something like a large language model, I can't just download the internet for training data, right? That's not possible.
Yeah.
Unlike a software and car company, or even like a company that's doing rigid body manipulation, like palletizing, case packing, I actually can't use simulation because simulation really assumes Newtonian physics and non-deformable stuff, whereas food is deformable, sticky, wet, malleable,
Yep. All the things physics
often
doesn't do
non-Newtonian.
well. Uh-huh. Or our current
Yes,
physics models in simulation.
classical physics. Yeah, exactly.
Yeah.
So simulation also doesn't work. So
Uh-huh.
then you're like, okay, well, you can bootstrap your data, right? You can kind of like in a lab bootstrap the data, which is fine to get started, right? But of course, as we talked about, given the highly dimensional nature of food and the number of ingredients, and the fact that every customer,
All
every kind
different.
of they're all different. Like that only gets you so far. I mean, I can bootstrap one ingredient or two ingredients, but I can't bootstrap 100 ingredients, right? So we went kind of back to the drawing board, and we're like, okay, well, who else did we talk to in this search when we decided what kind of customers to go after? And we stumbled upon, of course, production manufacturing, right? So initially, my impression actually was like, well, food manufacturing, that's already solved, right? Like it's kind of these machines that we've all seen kind of growing up with how it works, right? These are traditional automation systems that kind of just do the same thing over and over again. That was my impression.
Yep.
Um, what I learned is that there's another really big market within manufacturing called high mix manufacturing. High mix is essentially, well, the opposite of low mix. Low mix is kind of, you can kind of get these traditional pieces of automation. It's the Kraft Heinz example. and it's kind of solved, low mix manufacturing. Um, High mix is a little bit different. So high mix might be like, I want to make a prepared meal. And to make this prepared meal, I know that every human wants a little bit slightly different stuff. Some people want meat lovers meal. Some people are vegetarian. Some people are vegan. Some people are gluten free. And within these, there's 30 kind
Yeah.
of SKUs within each of these categories. So what we learned is that there's this really incredible market from a market size perspective where there's these companies that'll have hundreds of SKUs. And if you have
SKU
hundreds
is
of
an individual item, or what's an SKU?
yeah, like an individual meal, let's say.
Oh, okay. What does it
Yeah.
stand for?
So like each, I don't
Is it an
know,
acronym?
single, it probably is an acronym.
But it's a
That's
meal.
funny.
It's like an instance of a meal in a permutation
Yeah,
kind
like
of
yeah,
thing.
like I mean, like like different cans of like LaCroix are like
Yeah.
SKUs, right? Different, yeah.
Different flavors,
It's
you're
it's basically
saying.
like a
Okay.
identifiable product in your line.
Okay.
Yeah. Um, so okay, so it's like okay, interesting. So like, what's interesting about these though is that because they have hundreds of SKUs, they are not going to have hundreds of dedicated lines like the low mix companies do.
Hmm.
Instead, you're going to have way less lines, like 10 lines arbitrarily, and then you're going to do changeovers, which is to say you're going to kind of go from doing pad thai in the morning to Thai green curry in the afternoon to maybe doing a Mexican casserole at night. So the line is flexible, right? And so, of course, as you alluded to, traditional automation doesn't work. And the reason it doesn't work is traditional automation is really designed like you bolt to the ground, it just does that rice. And the rice robot is not, the rice machine, I should say, is not then going to go do diced chicken. But of course, for high mix manufacturing, you need that. You need something flexible. You need something to go from doing, pad thai to Indian korma to Thai green curry. So traditional automation doesn't work. So what I learned is that they use humans. And specifically, the way that production works is that you have these long assembly lines. And these assembly lines are often in very cold rooms, 34, 36 degree Fahrenheit rooms. And essentially, each person's on a station on the line. And with their station, they have an ingredient. So, okay, I'm making the pad thai. Person one is putting the trays onto the line. Person two is doing the noodles. And there's two lanes, let's say. So the person three on the other side of the line conveyor is also doing noodles. Then somebody's doing mixed vegetables, etc. What was really interesting from a technology perspective for us is that because it's much higher volume, the jobs are much more specialized. Now, Sally, if she were to work at one of these companies, Sally is on station three, and Sally is doing the broccoli. Now, Sally isn't just doing broccoli for her 8-hour shift. She might be doing, in 3 hours, there's going to be a changeover, she's going to do something else. But broadly, Sally is doing like 5 ingredients per day, right? 5 ingredients I can bootstrap in a lab. I can bootstrap the training data, and I can get something good enough to deploy something in the world, right? And this became our kind of like thesis, which is like, okay, look, we believe that for robotics, like really embodied AI to work, you need real world training data. Sim doesn't work, right? It can kind of work for some industries, but food, it doesn't really work.
No. Yeah.
Can't download the training data. There's no food manipulation data on the web. Bootstrapping only takes you so far. You really need real world training data. So it's like, okay, like we're going to bootstrap something just to get something good enough to add value to these customers to do 5 ingredients. If we can do 5 ingredients, we can ship something into production. If we can ship something into production over time,
You'll get more data.
We'll just see a lot more. Yeah, exactly. And by the way, if we get more data, then our AI gets better. We do better manipulation. What I mean by better manipulation is we're more consistent. We spill less. We don't damage the ingredient more. We can do more portion size. We can place it in different compartments. Like that's better manipulation. If we can do all of that better, then our robots are more flexible. If our robots are more flexible, then our current customers, like our current customer batch, is going to use those robots more. If our current customers have high utilization with their current robots, well, what are they going to do? They're going to get more robots. So now we have even more robots. So we have even more training
It's a
data.
virtuous cycle. Yeah.
It's a virtuous cycle. And by the way, now when I go to my next customer, there's a bunch of benefits here. First of all, I can
even
probably
better for
already
them.
have a good. It's even better for them because I have a good starting policy of how to manipulate. Maybe not all the ingredients, or even because their ingredients are slightly different. But I have a starting policy, right? Probably I have a good case study from my existing customer, right? I mean, I might even have operationally some local people who can actually help service the thing. So there's all these things that actually make the whole flywheel just get better. But of course, the core of the flywheel is the data flywheel,
Definitely.
right? So we're like, aha, this is kind of the go-to-market, right? And like, I just love to learn about like startups and business. So like I was like, it felt a little bit like we were trying to build the Model S before, which is like going directly to fast casual,
Yeah.
right? Sorry, Model 3 right away. And now is like, okay, well, really right now we just need to build the Roadster. And this is a Roadster.
Love it.
Just something that can like get to market, add value, and we learn how to like really build the technology and we create
Uh-huh.
this flywheel. But of course, the vision was the same. The vision of Chef has always been we want to deploy AI-enabled robots in the food industry, period. We
Yeah,
want to deploy
everywhere.
AI-enabled robot everywhere, into every commercial kitchen, right? Because by the way, like the market needs that, and the demand is there. Like, and if somebody were to solve this, like the demand is there.
Yeah, it would
So
skyrocket in like you have a huge market you could just gobble up.
that's right. So it was like, okay, well, how do we then kind of think, okay, we started here. We started with the Model 3. We'd like to go back there at some point. We're right now at the Roadster. And then we're like, okay, we have to connect the two dots. And, what was really interesting is, of course, if I can manipulate diced chicken in a food factory, well, why can't I do it in a ghost kitchen? And if I can manipulate diced chicken in a ghost kitchen, well, why can't I do it in a fast casual, right?
Ah,
Manipulation is manipulation. The hard part is manipulation, the grasping.
yep,
That's the hard part. Everything there's other issues, by the way, right? Like form factor. There's other issues.
definitely.
But those are engineering issues that can be solved. The thing that's like the hard thing is the manipulation,
Yep.
right? So we're like, so like, not only do we have this flywheel within manufacturing, which is like the more robots we deploy, the better the system gets, but that same training data and that same AI can then be used to go to step two.
Yep.
Step two for
Yeah,
us is ghost
exactly.
kitchens and cloud kitchens.
Hell yeah. Yeah, that's what I was meaning where it's like you guys can just you start with 5 products and then eventually once you have scaled up to 100 products or 500 products, then you can maybe then open your own kitchen and you have the robot worker
Yes.
part solved. It's like, but so, and
Yes.
then on the way to going from robot serving 5 things to robot restaurant, you can serve all the things that are in between, which
Yes.
is the
In
rest of the
between.
food industry. So it
That's right.
seems like
That's
a
right.
good growing plan to me.
Yes. Yes, exactly. So like right now we're focused on food factories, big giant food factories.
Oh yeah, might as well.
The next step is exactly. And the next step is kind of regional food factories. Regional food factories would be cloud kitchens, ghost kitchens. These are kind of smaller. They're kind of aggregations of restaurants. Right. By the way, they are essentially factories. I mean, they have a lot of real estate and they're delivering delivery orders. Right. So it is a food facility. It's just smaller than the ones we're going after right now. Lower volume,
Yeah.
right? And then finally, we get to kind of, if you think about like, right now we're like, you know, relatively we're kind of low mix on the relative scale to restaurants, right? But very high volume. And then, as we go to step 2, the mix gets a little bit higher, the volume gets a little bit lower,
Yep.
right? And then finally, when we get to commercial kitchens, the mix is back way at the top, but the volume is way, way lower again.
Yep. Hell yeah. That's super cool.
So that's kind of what we're thinking about.
Yes. And I would think if we're sticking with the like Model S to 3, then you opening your own restaurant, that can be your Cybertruck moment.
The robotaxi.
Yeah.
Yes.
Or the robotaxi, yeah. Okay, hell yeah.
Yes.
So that sounds really cool. Getting the data is very clever and you can train on that. And I think just to make it a little more explicit or make sure I understand, so you're getting training data on these 5 items that now you're in production and you're actually adding value for a customer. Now you're recording all of that data and you are then using that to train better general policies that you can use to bootstrap additional things. Is that kind of how it's working? Where it's
Yes,
and then you
more
can
or less.
you can add another 5 items or whatever it might be.
Yes, that's right. That's right. Exactly right. So like, I mean, I think like where we really started is like, if you think about a meal, right? The majority of the meal is what you might consider like scoopable, right? In other words, like you can use your hands or you can use like something like a scoop, like an ice cream scoop or something, to pick it up. And that's like things like starches, like rices and pastas
Yep.
and things like that. Then you have things like different meats, right? It can be like diced meat or shredded meat or pulled meats, things like that. Then you have different kinds of vegetables. Of course, like, there's lots of different kinds of vegetables, different combinations of vegetables, but they're always usually cut in some way. Then you might have a garnish, right? You might have something like a spice, or you might have like more vegetable toppings, something like
Yeah.
that. Maybe you have a sauce. Maybe you have something like a mash, right? All of these are scoopable.
Uh-huh.
They're very different, by the way. Like, shredded meat is very different than a cheese, and cheese is very different than a sauce, and a sauce is very different than broccoli.
Yep.
They're all very different, but they're all kind of like this. Like, you can kind of imagine an idea where, like, a camera to understand where do I pick from and where do I place,
Mm-hmm.
a six-off arm with the right manipulator at the, kind of the right
An
utensil
appropriate
at the end.
manipulator. Yeah.
Yes, basically the combination of computer vision, motion planning control, the right robot motion palette policies, and the right utensils can hopefully build a general policy
Yep.
on how to manipulate food.
Yeah.
And the more of these ingredients it sees, and the more it's basically breadth, like different ingredients, and also depth, like how
Yep.
many of this, like the same ingredients sees over and over. You can make a system that's very flexible, but of course it's still got to be very consistent. I think consistency is the hard part here, right?
Definitely.
Like, it's gotta, it can't be picking up, like, if it's a 1 ounce portion, you can't be picking up 3 ounces one time, 0 ounces the next time,
Yep.
half an ounce the next time. It's gotta be like basically very close to 3 ounces over and over.
Yep. Okay. So this, to me, this sounds like a very hard problem, and it also sounds hard to get your. So you are getting data, and I kind of understand in the abstract how more data is improvement. And you've mentioned so kind of robotic arm, appropriate gripper, and you're using mostly computer vision, and that lends itself from your background, which is really great. How is that the only is vision the only sensor you're using other than maybe like joint torques or something like this? And
Yeah.
then like how do you annotate your data? How do you establish what
Yeah.
was good or what was not good? How do you
Yeah.
use production data in actually training the system to do what you want it to do? Like
Yeah.
how does
Yeah. It's a
Go ahead.
there's a lot there, and all very
sure.
good questions. So, one thing that's really interesting is that most of our team is from the self-driving car industry.
Uh-huh.
So we have, like, the vast majority of our team is from, like, Cruise and Neuro and Zoox and Waymo and Embark and all these different
Yep.
AV companies. And of course, like, what you essentially ask is what AV companies are very good at. They're very good at, like, annotation and pipelines
Yeah.
and testing and test infra, right? So essentially, okay, so let's start at, like, where we started. So the first step, of course, is having the right metrics. So what are the relevant metrics? So consistency is one of the main metrics.
Yep.
So how do you measure, and that's consistent with weight, right? By the way, so, and this also gets to your sensors question. So of course we have RGBD. We have a couple RGBD sensors, but we also use force torque, and we also have weigh scales, essentially like scales, right?
Yep.
And so the way this kind of works is that what we can do is we say, okay, well, we have a topography. Based on this topography and the ingredient I'm picking and the other sensor data inputs I have, what pose do I pick at in the pan to be consistent, right? And again, that'll take into consideration a bunch of stuff, like the entire robot policy. It'll take into consideration any fine tuning the robot did before the production run started, which the robots fine tune themselves. Like, it'll pick and dump
Yep.
to fine tune itself before the production starts.
That's
It'll
cool.
take into account, yeah. And that's
That's a
because there's so
clever
much
thing. You're
difference in food.
calibrating. So you have
Yeah.
like your base layer of understanding, but then it's going to fine tune the network a little bit
Yes.
by picking and dumping just a few times to be like, okay, let me get the consistency of this. That's so funny.
By the way, it's a very practical thing, right? Because every batch of food is a tiny bit different. It just is.
Oh, definitely.
Um,
What a funny
so-
thing. Okay. I've seen people do that
Yeah.
too. Like if you see
Yes.
like people waiting while they're whatever,
Yes.
they'll pick and scoop whatever. And it's like,
That's right.
like they are calibrating in some sense. And that's so funny. The robot's doing that. Okay.
Yes.
So cool.
So then basically now we've kind of figured out, okay, what pose do I pick at? We'll execute a pick. And then of course what our scales do is, like, they're kind of takeaway scales. So, like, we can measure the weight lost from the pan of food. They're underneath the pan of food.
Yep.
So we measure the weight lost. What that allows us to do is close the loop.
Yep.
Okay, we based on
So you're
the
making your own
policy-
supervised training data,
Yes,
basically, because
that's
you
right.
have that scale and it's all weight driven.
That's right.
Interesting.
That's right. Well, so that's one
That's
metric,
one
right?
dimension. Yeah. Okay.
That's one. So it's probably arguably one of the most important
I would
ones,
bet.
but that is one of them. So weight is one. Another thing we think about is, like, placement, right? So, like what we do is we have a neural network that basically does like the before and after. It's kind of like QA, so we like it's part of our product.
Yeah.
So what we can do is we say, okay, look, like we like the food to be distributed like this, whether it's like in a clump or maybe it needs to be spread out or whatever the customer wants. The customer can actually kind of like we give them a nice web app where they can say how they want the food to be placed,
That's so
right?
cool. And they're
And
like, I
then
want it dispersed like this or kind of mushed or like a perfect
yeah,
ball that
yeah,
looks like the
yeah,
serving
or in this
thing.
compartment or
Or in this
whatever else, right?
Okay, that's really cool.
Yeah. And then of course what we can do is use we can have a before and after, right? And then we can give a scoring to that. So like how good was the deposit from a placement perspective? So that's another metric we have, the placement quality basically, right?
So you just look at like the difference in the before and after image, and then you assume that that's what was placed, and then you evaluate that based on some intended placement,
Yeah.
I suppose.
There's a bunch of different ways to score it, and like, different
Yeah.
customers care about different things, right? But like, we have depth as well. So we can see, okay, well, like, what does the mound look
Yep,
like?
exactly.
Or maybe they care, maybe they care just about like, look, we want the entire thing to be covered. Like, there's different ways to score it, but there's some score we assign for the placement for that customer, right? So that's kind of metric two. The third metric we look at is throughput, because of course it needs to be fast. Like if it's not fast, then like honestly it's not great.
Yeah.
So that's another metric we look at. Another metric we look at is kind of just core reliability. And reliability, I mean, there's many dimensions to reliability, but some to call out would be things like missed bowls. Did we like detect a bowl, but we couldn't place into it for whatever reason? Did we do a double deposit where we kind of tried to place twice? Did we
These are bugs, basically. Yeah.
yeah, like basically bugs and reliability. Did we try to accelerate so fast that we use collaborative robots? Did the robot protect to stop, right? And so that also gets taken into consideration. So anyways, we have metrics for like the most important things our customers care about, and all of that's kind of considered when you're kind of making this policy to make sure that like you don't get a system that's flexible, but then like it's super slow.
Yeah.
Or it's flexible, but it's spilling food all over the place. Or it's flexible, but like it's super ugly when you place it, right? All of these things need to be taken into consideration. And then, to final part of your question was like, okay, well, the data annotation and stuff. A lot of it's automated. So we've built a lot of tooling to do this. So like if there's a high weight event, right? Like, we wanted X, and after some sigma standard deviation, we'll automatically kind of annotate that and say, oh, this was a high weight event. Let's collect we use ROS, so let's collect a ROS bag of like all the information, like a little bit of the information before and after, along, and now we can debug it, right? And all of that, we have a data pipeline that's all, as soon as that event happens, the robot will send that rolling record to the cloud, and then we have a nice interface where we'll get an alert on Slack, and if it's a P0 or L0 alert, PagerDuty, and then the person on call, the customer support person on call, can if it's really kind of production downtime impacting, like they can actually kind of like triage that. So that's I kind of talked about the support process, but that same thing is used for the ML too, right?
Yeah.
Because like if there's issues, like we've automatically annotated everything. It's kind of one and the same process. Like it goes different places. Like one's for support, one's for training.
Makes sense.
So,
yeah, you take the data, you route it both places. That's pretty cool. Yeah, I like that quite a bit. That's so you're getting your data, and then you do the scooping to fine tune. Is there any trick involved with going from like I guess you try to probably sequence the food that you work on based on its similarity with the past foods that you've trained on, so you don't go from like all rice to shredded chicken or something that might be a big difference.
In terms of like our own training?
Yeah. So in terms of like, so you support 5 items, say. If you're going to add item 6, you probably, if you did like rice and a bunch of other small grains, then you probably don't want to go to shredded chicken or broccoli or something like this. That's a big departure from it.
Yeah.
How do you sequence the items you add?
Yeah, so it's actually an interesting question. Like this is actually like if it was like perfect world, we do exactly what you're saying. But the thing is, like now that we're in production, like, again, this is kind of a sequential story.
Yep.
Now that we're in production, we have a customer's paying us money. We kind of have to do what the customer wants.
Yeah.
So what the customer wants is the ingredients that are the toughest for their people,
Ah.
right? So like, and this was interesting, right? Like, we learned that like risotto, which is a very thick, viscous material, it's like really hard because you're
Is that
like
like cheese?
scooping it for eight
Risotto means
hours.
cheese, right? Or is it
It's like a cheesy rice,
cheesy
yeah.
rice? Okay.
It's very dense, basically, right? So it's like a hard, like your arms are hurting, your
Yeah.
back's hurting, right? Like,
You have a lot of work to do to pull through it. Okay.
for example, right? My point is that like sometimes we didn't have like we it's kind of like it's a negotiation. Like, hey customer, we've done your basmati rice. How about we do your brown rice? The customer's like, no,
We're
I know
good
you
with
can do
the
that.
brown
Like, I want
rice.
you to do this,
Yeah.
do this. And so it's kind of negotiation, which of course isn't great from a purely technology perspective because, like you said,
You
they're
would
quite
want a
different.
sequence. Yeah.
You would want to sequence it, but sometimes you're not able to. You kind of, as an early stage startup, you kind of take what you can get.
Yeah.
Um,
Makes sense. So then what you probably do then is you take whatever the material they want and you can bootstrap something with it, and that gets you working good enough. And eventually, maybe your learned scooping
yes,
policies will be general enough to work with a lot
yes,
of things, but you're
yes.
bootstrapping specific things that
That's
you need to work.
the way we kind of thought about it is like, and again, this was like, it's changed through the years, right?
Hmm.
Like per class, we'd have like policies, right? Right, if you will, like a
Yep.
class of food, like a mash is a class of food. And it's a very different
I
class
love
than
how
like
technical.
a,
I just talking to you about this. Like, I don't know very much about the food industry, but having you and you not being a food person, but you've come in and you are dissecting it, and you have like this,
right.
I don't know, semantic understanding of.
Yes, it's like a
Yeah,
taxonomy
yeah,
almost,
exactly,
yeah.
exactly. It's so funny.
Yes,
But okay, so you have your
yeah.
mashes and all these other
Yes,
different
and they're very
classes.
different than exactly. So we basically had like different policies per
Yep,
class, and it was kind of like an inheritance tree almost, right? So
yep.
like within a mash, then like you could have like a cauliflower mash is probably pretty similar to a potato mash.
Yep.
I just made that up, but you get the point.
Yeah.
So that was good enough to kind of get started,
Hmm.
right? Like you said. And then of course as you run it more, you see more mashes, you see more pulled chicken then or pulled meats, then like your entire policy gets better.
Hmm.
And then over time, what we're trying to do, of course, is to have more of a
Unified.
generic,
Yes.
a unified policy, right? And of course that's where things
That's
like
the holy
diffusion
grail
policies and
for this.
exactly that. And by the way, the new stuff, right? The diffusion policies and learning from demonstration
Yep.
and all of that work is really really important for that.
Ah, okay. I would like to talk about that more later. Let me write it down. Yeah, learning from demonstration and all that. It's very interesting. Are you guys using learning from demonstration? Is that how you're
Yeah.
bootstrapping?
Well, at the beginning, no, because that didn't exist.
Yeah, because
Like,
it seems
but more,
pretty early, although there are some pretty compelling research results lately, although I don't know all the caveats to the demos
yes,
that I've seen and things like this. And I keep
yes.
finding more when I look. But
In the early days of Chef, right, like in 2019, 2020, this wasn't really like
it wasn't
obviously it
feasible.
existed.
Yeah.
It wasn't really good, right? Imitation learning wasn't really. If imitation learning kind of felt like reinforcement learning, which is like, yeah, we're gonna do it, but I didn't. I honestly, I hadn't really heard of companies who had productionized, right?
Yeah, not
RL
many.
or IL. Yeah. As of late, though, I think there's a lot more exciting work. So what we are doing now is like if we're trying to onboard a completely new class.
Hmm.
So I'll give you an example. Like we are now
Jello.
we've now productionized.
Yeah, I don't know.
Yeah, actually, even more interesting. Like we're doing kind of like picking like one chicken breast, right?
Oh,
That remember I talked about like a meal, right? It has
yep,
like all these like different ingredients. Sometimes at the top there's like a piece of meat,
yep.
right? A piece of salmon or things
Delicious.
like that.
Yes.
So yeah, so before we'd have to like bootstrap and then kind of like get production data and like there's this whole thing you got to do to like onboard a new class. That takes some time.
Yeah.
Um, with LFD and IL, that time is a lot
Learning
shorter
from
because you can have 60
demonstration and what was that? What's IO?
imitation learning.
Imitation learning. IL?
You can
Okay.
kind of have yeah, you can kind of have like
You can speed it up
60 or 70
way faster.
demonstrations.
Yeah.
You can speed it up much faster. So, I mean, like you said, it's definitely newer, but I think we're finding some good results there as well. So,
Cool.
we're thinking that that's actually going to be a really powerful way to really accelerate that flywheel.
That's sick.
Because we already, and by the way, the to do learning from demonstration well, like it's a combination of the demonstrations and production data now.
Yeah.
It's not just the
Oh,
demonstrations. It's
you
like
have your
we
own
combine both of them.
demonstrations. That's super, super cool. Yeah, so you
Yeah.
can choose a more stable algorithm or something because you have all of your data from
Yes.
your robot actually doing it.
And it's labeled. It's like supervised,
And
right?
it's
It's labeled data
supervised.
too.
Yeah. Oh, that's a super cool thing. What do you think? So, in the recent learning from demonstration work, I haven't really looked into it too much. What has changed? Why is it better? Is it like all this transformer? Are we using transformers and is that why it's great now or what's
Yeah.
happened?
I think transformers are quite powerful.
Yeah. And
So I think yeah, trans
that is it. Okay, I didn't actually research into it, but transformers as far as I understanding give a better weighted look back at context from the
yeah,
past. Is that
yeah,
is that a
yeah,
fair
yeah,
explanation?
exactly, exactly. And I think it I mean, so I think I think transformers are really helpful because you have better like it's kind of using like it's a diffusion policy, right? So it's kind of similar to the same. It's similar to the technology that like something like a Sora might use or like DALI might
Yeah.
use, right? It's like you're generating an image right here. You're generating a policy, you're predicting like the in joint space, like where like what the joint of the robot should be, right?
Hmm.
So I think the transformers certainly helped. Um, but I think it's like it's really a bunch of things coming together, right? Honestly, it's like GPUs are also getting better. I think the VR technology, right, to be actually able to kind of like do the demonstrations getting better.
Hmm.
Um, I think there's a bunch of things, but I think yeah, like the pivotal thing would probably be transformers and diffusion as an idea really becoming a thing.
What a thing. Okay. Yeah, it's amazing. I do feel like robotics is changing. Like the technologies
Yeah,
that we use as an industry are really gonna like the next 10 years is gonna be different than the last 10 years. And I know that kind of seems
yeah,
obvious, but it's like a lot of the things I even learned in school, which is not that long ago. Like I was in school 5 years ago or something like this, are not used anymore. And we have different methods for
yeah,
doing things. It's crazy. And I
yeah,
mean, some of the low level stuff, like say A star or something, like we still use that
yeah.
for navigation, more optimal planning in some state space or something if it's small or RRTs or something. But a lot of these perception and manipulation tasks,
Yeah.
they just it seems like these, like imitation learning and all the machine learning and AI, it's like they're fundamentally different approaches and they enable a lot more performance and handling of less structured environments.
Yes. And you know it's really interesting. So like I alluded to, most of our team is from autonomous vehicles.
Yep.
I'm like honestly like I'm not the expert as much as they are, right? But you know the AV industry kind of went through this, right? Which is like the AV industry for a while was very much rule based, right?
Yep.
Like detect red light, right, and then
Yeah.
you stop, right? Or you detect the car and then you track the car and then you make sure you don't like when you're doing a lane change you don't collide with the car.
Yep.
I mean I'm simplifying, but you get the point.
Hmm.
It's very much rules based. But then what happens is that like the world is
Super
highly dimensional.
confusing.
So it's confusing, and then you have all these like it's just extremely kind of wrangly code where like
Oh,
it's like
yeah.
all these rules, right?
Oh,
And
totally.
like of course you can't get to every edge. And by the way, there's still a lot of machine learning. It's a lot of machine learning, but it's like rules.
Yeah.
Like it's
It's
detect the red light and then stop.
Yeah, it's the machine learning is a lot of time for like weighting things, not for
Yeah.
like changing what it does per se.
Yes. And that same thing was true for us, right? So we
Huh.
started off that way, right? Because that was kind of what the industry did, right? And
Yep.
like if you're doing robotics in 2020, of course that's what you're going to do. That's what
Totally.
everyone does. Um, and I think that was fine because it got us
Yeah.
started. But I think what you find is that like you have these like very gnarly policy. Like our policy at that point is like 200 parameters, right? Just to like kind of manipulate an ingredient, and
Yeah.
and that works fine. But then like the customer, like you go from like customer one to two, and customer two has the same kind of
Yeah, you need
let's
another
say
policy.
cucumbers.
Another
Yeah, but
200
and exactly, and you can
condition
have this
policy.
inheritance idea, but it's different.
Yeah, I think a lot of times with this, you make a design architecture and then you find out by some awful exception that you need data routing from one spot to another where you didn't intend and it's incredibly painful to get it. And then the whole thing becomes a hairball if you do it, or you have to redesign, which is painful, especially if you have your
Yeah,
200 conditions. So,
yeah,
yeah. Whereas this, you just learn and it learns all the connections for things and
that's right.
you don't have to worry about that hairball of logic. And maybe
And
it
and
can
I
be
think
more
one thing
general.
I think like I at least from what I've understood, a lot of the AV companies are also kind of like now going in this direction.
Yeah.
Like I think like Wave, for example, Wave, I think like in they just raised a big round, and
Yep.
like for a while like this end-to-end learning idea was like, I don't know, people are very skeptical about it, and then people still are very skeptical about it. I think
I
many
still
people are
have
still skeptical
plenty
about
of
it.
skepticism about it, but I think there's a
Um,
lot of potential too for specific problems.
yes, and I think Tesla FSD 12 is like one interesting example of like many people, many friends have mentioned that they like really like FSD 12, and that's like
Is it the
I don't know
current
if you know, but like
operating system
that's the new
for
one, and
the
apparently
Tesla
that's
cars?
the one where they like,
It is
yes, and
self-driving.
they
It's a some level.
but apparently they actually like they cut like 300,000 lines of code, and they're really
Yeah,
using imitation learning to actually
it's
like,
crazy. Yeah, what a cool thing. I can't wait to try it because
yeah,
I see great things about it. But
yeah,
okay, so yeah, and that's an end-to-end approach pretty much, I
yeah,
think. Like
that's right,
you have code to hook up stuff and then the rest of it, like the policies probably mostly
yes.
learned.
That's right. And like, what's nice by the way is that like, we can do like I think the winner I really am convinced about this now more than ever before is like the winner in AI plus robots is going to be the companies that have the most production data. Like you
Definitely.
can and should use imitation learning. Like that is useful to get started,
Yeah, but it's
right?
a
But at the end of the
bootstrapping
day,
method.
it's really good for bootstrapping, but at the end of the day, every in our industry, like food, I mean, it applies for really any robotics problem. But like in the food industry, like every customer is gonna have different broccoli. They're gonna cut it differently. They're gonna cook it differently.
Hmm.
It gets you started, but you just simply need to deploy lots of robots at lots of customer sites. And by the way, different within the same customer, different customer sites are gonna do it differently.
Hmm.
And so you just need a boatload of robots in the world to really have enough data to actually make this all like really work well together.
Yeah, it's a really interesting approach. And it's the challenge that I think it becomes is how do you grow your company through the stages as you are collecting data and automating more and more of the process? Because you have to find the
Yes.
clever low impedance way to
Yes.
grow your company because you can't go, let me go nothing to solved all the way and I'm going to deploy all this
Yes.
money and lose
Yes.
it all to just try to see if I have market fit or something. Like you have to
Yes.
gradually grow,
Yes. Yes.
and
By the way,
it's what you're
you
doing.
said you said you said something really interesting, right?
Go
Which is
ahead.
basically like, like you essentially kind of called out the Cruise and Waymo approach, which is let's raise tens of billions of dollars and let's like just jump to the end goal,
Yep.
versus the Tesla approach, which is, hey, let's just ship a vehicle. It's not going to have any autopilot.
Yep.
And over time, we're going to have billions of miles of FSD, and like hopefully one day, like we have a really good autonomy system.
You're
Um,
right. Yeah. I didn't mean it intentionally, but yeah, I think that is a good it is the different stories that you see there.
yes,
And
exactly.
uh-huh. And it's also you guys, it's Electric Sheep. Like you and Electric Sheep to me are taking a very similar approach, which I think makes a lot of sense. Of
Yeah.
just getting lots of data, deploying out there, starting as simple as possible, but then
Yes.
growing into
Yes.
complexity.
That's right. That's right. And yeah, I'm getting like I think for startups, like look, if you're like like there's certain companies who can do the Waymo approach, right? But I really think for startups, like you kind of like you said, you have to find like what's the Uber Black, right? Like what's the thing that you can get to market, or what's the Roadster, or like what's the like Microsoft like MS DOS, like what's
Yeah.
some like the
To
basic
start up that
thing
flywheel.
to start up that flywheel. Like, what's the Amazon selling books on the books
Yeah.
online,
Your entry
right?
point, your beachhead or
Your entry
whatever to the
point.
rest of it.
That's right.
The thing,
And then
oh,
and then you have to grow that, but while
mhm.
also telling the story, because like from a fundraising perspective, like Uber Black honestly is not that exciting. Like another a taxi
That's
service
like
for
the
like rich people is not that
luxury
exciting.
Uber.
Yes,
And is
that's
that where
where
they
Uber
started?
started.
Okay, I didn't know. I
That's
don't
where
know
they
much of
started.
this
They
history, but okay.
they basically had like it was literally a limousine. It had people wearing like a nice like suit. It was like super high end,
Yeah.
right? But it allowed them to get started. And wealthy folks in San Francisco used it.
Yeah.
But over time, of course, they built
They
UberX, they
grow.
built Uber Pool. I
Yeah.
mean, and
And that's
now
Tesla.
Uber's 100 billion. And yeah,
It's interesting because in my mind, like, okay, I bet so I guess there is nuance in this in that there are very different ways of starting this. You can do the Uber Black or you can do the Tesla approach where you go for the luxury markets and that's a way of spinning up production. You can go, like the project you're doing as far as I am aware, it's not like the luxury and food part. It's a very pragmatic, useful part of the food
Yeah.
preparation one. You have
Yeah.
Amazon with their sending books by mail. That's not very, I mean, I guess maybe that's richer people that are reading and want access
Yes.
to their books. But I guess it's just
I guess what it's not.
finding your market initially that is a
That's
low
right.
investment.
I think it's finding the people. It's not even like wealth per se, but it's like finding the people who have like big pain points. So in the
Ah,
Amazon use case, right? It
love
like
it.
what I mean by that is like in the Amazon use case, like the pain point they were solving is like if I want a long tail book, right? Like if I want like if I were to rank books, if I want the 10,000th most common book, right, in the
It's not in any
country,
bookstores.
and
Yeah.
yeah, exactly. Like, and I live in like Omaha, Nebraska. Like, I probably can't go to the bookstore next door and find that 10,000th ranked book. But Amazon's kind of clever insight was if I can aggregate all the books into a central warehouse, then I can have
All
20
those long
copies of the
tail ones.
10,000th ranked
Yeah.
book. You can have all the long tail ones. So it was kind of like solving like a big pain point for like book readers, which is like, I want this long tail book, and now with the internet, I can take advantage of it,
Hmm.
right? I think for Uber Black, it's like, I mean, it's a different analogy, but it's like, okay, well,
Who
it's
would
like
pay for this? Rich people who
who
want
would pay for it?
convenience,
That
this
yes,
kind of thing.
and I think for Chef, it's like, given the technology available today, right? Which like, what's the market that has the biggest like again hair on fire problem where I can actually add value, which is food manufacturers.
Hell yeah. That seems great. Let's see. And so just kind of the last part of the picture that I don't really understand, or I guess it has have some ambiguity around. So the end effector or end effector to the robot, it's mostly a scoop, but you're looking into like pinch grip or something, so you can pick up chicken or different meat
Yeah,
chunks.
it's a good question. So the way you can think about it is like, and like let me talk to you about like what it is now and like kind of how I would think about it.
Sure.
So each robot, so each of our systems, we make modules. These modules are basically the exact same hardware. Every single customer, without exception, has the same hardware. That's like a hard and fast rule for
Love
us.
it. That's so much
Because we
better
don't
for
we don't want to make
maintenance.
maintenance like that's how you have like that's how you build a scalable business. I
And
think, right?
also
Not making
your
custom
data,
stuff.
like it makes it easier for you
Yes,
to train your data because you all have the same setup.
it's homogeneous. It's more homogeneous, like you said,
You need a
from
good
like a geometry
upgrade
perspective.
path probably for like, oh, you want to swap your
Yes,
sensor or something. Like I'm very
yes,
curious to how you solve that problem, but I'll ask that in a bit. So, okay,
yeah.
you have this
So
homogeneous setup.
yes, exactly. So the module is the same. It's the same footprint as a person, and then from an end effector perspective, we each of our robots, without exception, has the same actuator. Actuator, as in like the pneumatic actuator itself, and then that actuator has different has an interface, and on that interface we have a set of different utensils. We have a library essentially
Hmm.
of different utensils, and this library, what's interesting about this library is that like it scales very logarithmically. In other words, like there's like I said, there's trillions of different ingredients, and the way that a particular ingredient was cut and prepped yesterday it will never exist in human history probably ever again. That particular way,
Yeah,
right? Um, um, but that doesn't mean you need thousands of end effectors or thousands of utensils. We have a small class of utensils. We mass manufacture them. We have patents around all of them,
cool.
and that's it, right? Like we send the entire library to our customers. So each customer has an entire library. Each customer gets the same hardware. Each customer has the same code base software,
Hmm.
and then of course there's different policies based on what you need for your ingredients that
Totally.
you're actually manipulating.
Yeah. Okay, so almost everything is the same except the end effector may vary with the food, and the policy varies with the food most likely. And so that lets you control a lot, and you get to reuse a lot of the same code and everything like this. And then you just get
It
to
also means that it
find
can evolve. Like
it
the
evolves.
brain gets better.
Yes, yeah,
The
yeah.
brain gets better. Like if you have too much bespoke stuff, like it seems like sometimes we'll talk to our customers and we're like 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 you're like like they're like, oh, you're not making me custom stuff. But no, that's not. That's the whole point. The fact that it's not custom means that like your thing's gonna get better literally every week.
Yeah, that's so cool. What a funny thing where it's like, no, 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 because we do this generalization, we are able to benefit from everything that occurs. And that's really nice.
Yes.
How do you, so what's your, do you have a plan for how to like upgrade your hardware. So if say,
Yeah.
I mean, I'm sure you did a ton of research before so that you could lock in and feel confident, like look at the supply chains, look at the costs,
Yeah.
look at the ecosystem and the support. So lock that in, a really good one. But a painful thing that I have not yet seen a very good answer to is the eventual process of upgrading. So yeah, it's 5 years later and a new camera comes out. And I guess maybe you can mix the fleet or something like that or something, or provide, actually probably just put both on and then you can relate it. But do you have a good upgrade story yet, or
Yeah.
what are you thinking?
Yeah, totally. I mean, updates and upgrades are both part of the robotics as a service
Yep.
story. So maybe we talk about both of them because I
Sure.
think they're both kind of relevant. So, you know, here's the way we think about it, right? So like the hardware itself is mostly off the shelf for us. Almost all of it's off the shelf.
Love it.
Why do I call that out? There's a bunch of benefits you get from that. Number one, each component has been productized by a different company. And these are really great manufacturers, right? So like our CPU or our GPU or our HMI, the touchscreen, or our light tower. There's some manufacturer who's world class at making these components. And so what that means is our mean time before failure for the hardware itself is quite high. In other words, the hardware actually doesn't
Yeah, it's
fail very much.
robust for
Period.
sure.
It's robust. Number two, another benefit of that is that we
Didn't spend
have built our
engineering time
software.
on it.
Yes. And the software is built to be hardware agnostic. So what we can
Oh,
do is we have 3 or 4 different vendors per component. So if any particular component vendor is having some supply chain issues or whatever, well, great. Well, we can go to them. So that's really nice.
how does that
That also, by
work?
the way,
Like I'm imagining, is it like you have three different vendors where you can buy depth cameras from, and it's a all like, so one you're using an Oakley, a RealSense, and something else.
yeah, the code base is built to be hardware agnostic. So like basically, there's like a capture node,
Yep.
right? And like the camera capture node can have like the core code, the core like logic is agnostic to the hardware.
Oh.
But there's like one file which is like, okay, like the drivers for that particular camera,
Yep.
if that makes sense. And then you can say, okay, well this instance is using this camera node, basically camera capture node.
Yeah.
Or that same thing is true for like scales. Like we can very quickly bring up new hardware in our stack, or
That's
like
nice.
new robot arms, or new sensors, or like maybe we want another camera. Like we can very quickly bring up new sensors trivially, not totally true, basically trivially.
Yeah.
Because we've designed the system to be like extremely modular.
Yeah, so you can just sub out parts of it. How does that work with your training data? Or does it matter because the things you're labeling are, you can control everything anyways? Like you're just
Yes.
getting an RGBD image and you're
Yes,
just
I
moving
think
in joint
it's
space.
a very good question. Right now, like I'm saying we could do this. Honestly, we've been pretty happy with our components so far. There hasn't been a big leap. But you'd be right. I mean, that would be a concern
Okay, yeah.
to think about.
But I get what you're saying, where you've built it in a way that everything is modular. And that's definitely, like, as far as I'm aware, that's the best practice for sure.
Yes.
To make it so that
Yes.
you're not like super coupled to, you're just
Yes.
using like general ROS architecture
Yes.
principles, which is
Yes.
great.
Yes, exactly. So, by the way, this very well leads to service and upgrade. So, okay, from a service perspective, let's say some part of the system breaks, and so of course, well, we have a Pareto of like hardware failures, right? That we try. Our customer support team
You mean a
tracks.
Pareto distribution? Is that what you're referring to?
Yeah.
Nice.
Yes,
So
exactly.
80-20 rule
And-
kind of thing?
Yes.
Okay,
that's
so
right.
20% will fail 80% of the time. Is that what you're saying?
Yes.
Okay.
Yes. And so then what we can do is we can have FRUs, field replaceable units, for things that might fail frequently. And oftentimes those FRUs we'll kind of just like ship them initially with the deploy, like a new robot. Like we usually ship starter packs, like 6 robots at a time for a new customer. So like you get a starter pack, we'll ship you some spare parts from the get-go, right? And then of course like we'll also have them at our HQ, so we can overnight them if something actually needs to break. By the way, this is a very rare occurrence because our mean time before failure is like 180 days. So it's like it's not like hardware is failing all
That's
the time.
awesome.
So
Love it.
so
Especially
then,
for
then
like
if something
how early. I mean, like you guys are clearly put together and everything, but it's like you're still beginning. Like you're not at
That's right.
scaling just yet, I think,
Yes.
right?
Yes.
And so the fact that you're failing this infrequently is just wonderful.
Yes. Yeah, it's funny. Like we've stayed under the radar quite a bit, and now is really when we're like really starting to scale, which is cool.
Oh,
So,
hell
we can
yeah.
talk more about that too.
Yeah, sure.
Yeah, yeah. But yeah, back to the service and upgrades. So like, then what we do is we actually have partnered with a third party service org. Um, so these guys have like 10,000 technicians all over the world.
Hmm.
So from a scaling perspective, we can deploy. And that's what we talked about Europe a little bit. Like we're not super.
Geographically
There's certain
constrained.
things.
Yeah.
Yeah, like certainly there's things to be careful about because of course we want the best
I would think their data
success and service.
policy
Like
and stuff might be things you might want to watch
exactly.
out.
So there's legal financial ramifications that do need to be taken care
But
of.
you
But from an
could
operations
literally do it.
perspective,
Yeah, from an operations point, you're fine with it.
yes, that's right. And so
What a silly thing.
so what'll happen? What'll happen is like we have a really nice repair manual, like a giant repair manual.
Yeah.
Right. And like we'll train the trainer, if you will. Like we'll train their like person who trains other people. On how to do these repairs with these fruits. And anytime something actually fails, we'll say, hey, we got an alert that something failed. The customer told us something failed. They'll drive out an hour because everything's an hour away from wherever they might be in the country
Okay.
or North America, and they'll change the part. And if they need to, they'll FaceTime us. So that's like servicing for any hardware. And then from an upgrades perspective, I think it's a very similar thing. So we do these like ECOs, basically, engineering change orders. Where it's like, okay, well, we liked. So I'll give you an interesting example. Like we had these scales that we had shipped, and they were like IP67, which is already fairly high water ingress rating. But we're in the food industry, and people like
They
love
want
water.
super
They
high.
spray everything down.
Yeah.
So, anyways, like there was getting water damage, and that was right when we deployed. Like early on when we deployed, this was happening. So we did an ECO, and we changed out to IP69K scales, and like it was pretty simple. We just shipped them out, and you just install them, and like again, like it's very. We already have another node for the new driver for the new scales, and you're up and running. So I think upgrades, because it's so modular. It's not so like for example, there's no PCBs at Chef.
Yeah.
Like it's like electronics are all off the shelf,
Yeah.
right? It's like there's a DIN rail.
Yep.
You know what I mean?
You just
very
connect
simple.
it. That's it.
It's extremely like if you were to look at it, it's an extremely simple hardware system. Which, by the way, it seems simplicity. I think is really hard to do. So I think like there's a lot of complexity in the software. By the way, there's because we don't have hardware complexity, we have a lot of software complexity. But from a hardware perspective, then like if we need to change out like there's a new PCAP display that we're gonna do an ECO for. It's like much more reactive. There's like multi-touch and like it's nice because in food facilities you have like gloves.
Oh.
So it's like So anyways, there's some oftentimes these gloves have food in them. So like there's some practical reasons why we're doing this. But like you want to change out the touchscreen, no big deal. You want to change out the camera, no big deal. New GPU, attach it onto the DIN rail. Like
Yep.
it's like yeah.
That's really nice. Yeah, I would. The only concern that I would have with new parts would be that it would hurt your ability to reuse past training data. But I guess
Yeah.
that you're working on a number of platforms, that is going to be in your favor because they're all going to be a little bit different. And then I would imagine if there's like, I mean, maybe it's just good enough. You just pass the image and it figures it out. But I would imagine like, say it's like a slightly different resolution, or the colors are a little bit different,
Yes.
or something like
Yes.
that. I could imagine that the camera
Yes.
could mess
The
with
camera
things.
itself is quite important.
Yes.
Yes. No, you're 100% right. You're 100% right.
But the rest of it, yeah, it makes perfect sense that you could swap the touchscreen and that wouldn't have any negative impacts for this kind of thing. And
By the way, one thing that's also pretty
ahead.
cool that's happening in the world, which I'm sure you've seen, is like there's like exponentially decreasing prices for stuff. Like back in the day, like it used to cost $60,000 to buy a robot arm. Then of course Universal Robots had this big breakthrough with collaborative robots, and like they got it down to like 30 or so, right? And now like I mean, there's a bunch of new companies. Like Doosan Robotics is one that just went public in Korea, and like they have this really nice arm that's like substantially cheaper.
Hell
right?
yeah.
And like and by the way, that's just like I'm talking about like robot arms, but like even the Intel RealSense camera is $200, which is insane. Like the Jetson suite at Nvidia. I mean, there's all these components, and their cost is so much cheaper.
It's amazing.
Right? And so like, I think that's really cool too. I think the hardware, like people talk all about like we're talking about transformers and all this stuff. Like the software's obviously getting really good, but I think the hardware is also getting much better and cheaper, which is really cool.
Totally. And you need it to do things in the physical world. Like you need inexpensive sensors and things like this. I don't know. One of the things that blows me away is I was an undergrad maybe 10 years ago or something like this. And I did an internship at a company and we were using an RTK GPS. And it was like a 10K GPS or something like that. Like it was absurdly expensive. And don't quote my numbers, but ballpark of what I remember. And now, I mean, companies are getting them for like $100 or something like really, really low. And it's
Yeah.
really amazing. So you're seeing that fall, especially, I think part of it is maybe more efficient processes for things. And then another part is larger markets. Like robotics is growing
Yeah.
up and all the cars are
Yeah.
using sensors. And because
Yeah.
of that, there's more
Yeah.
demands for sensors. So then it's more efficient, is what I imagine.
Yes, and by the way, I really hope, I really, really hope that this like recent advance, or like I think ChatGPT was really um, awesome actually because it like inspired the world to do AI. Like you know what I mean? Like before then, like if you remember, like during COVID, crypto was the cool thing, right? Like
Yeah.
and like you know like
I love the point.
um,
Yeah,
I think like yeah like I it's a broader point, which is like I think the world needs like like a figurehead, right? It's like the 4 minute mile. Somebody needs to do the 4 minute mile, and then everyone else comes after. In EVs, that was Tesla. Tesla did
yep,
EVs, and now everyone's doing EVs.
yep.
In semiconductors, there's Intel. Intel like really like productionized the the transistor into an integrated circuit, and then sold them. And then of course there's lots of people who are doing integrated circuits,
Yep.
right? Facebook did this for social networks, and Uber did this for marketplaces. I think OpenAI did this for AI. Now AI, like the AI they're doing is more large language models,
Yep.
but they've woke the world up when it comes to like AI, which is I think really good because now there's a lot of engineers, entrepreneurs, operators, investors,
Yep.
writers, journalists, everyone else who's thinking about AI, which is really good for the world. And what's interesting is that what's the natural progression of this like hype or yeah, I guess it kind of is hype.
Definitely.
Um, what's an actual progression? Well, I think it's like two things, right? Like one is like people are more interested in energy, right? Like how do you actually get the energy to actually power these models,
Yep.
right? They're really interested in compute, so GPUs is a very natural extension. And of course, what's the third one? Robotics.
Yeah.
It's like you take you take these models and you apply them in a physical world environment. So I'm hopeful that this energy that we have around AI right now will kind of translate to a lot more breakthroughs in robotics,
Hmm.
but also just like a lot more people doing robotics and deploying successfully and scaling robotics companies. And hopefully if there's at least a couple winners, right, that
Oh
really
yeah, Greece
scale
for everything
hundreds of
else.
thousands of robots, everyone else it'll kind of open the floodgates. It'll
Definitely.
inspire other people to do it.
Yeah, I think it's very true. I also think there's additional market forces that are making it so that robotics is heavily invested in, like the labor shortages you mentioned.
Yeah.
Because there is the point where, like, what was you said like something like there's like 30% labor shortage, or what was
Yeah, exactly.
so that might get worse. I think it's kind of
Yeah.
likely that that gets worse. I mean, a lot of people are
Yes.
retiring. The biggest
Yes.
cohort, the baby boomers, are retiring. And so they
Yes.
were largely blue collar workers, or a lot of
Yes.
them were blue collar workers. And so then we're going to need robots. And so this is going to drive robotics investment because they are a feasible solution. Like there's technical risk, of course, but like if you set up a company in a smart way, like in my opinion, you guys are doing, like that, you can really dig into a lot of these problems and make a lot of value. And you don't require like a massive overhaul of all the facilities that they do the work in. You can just kind
Yes.
of drop a robot in.
That's right. That's right. And I think yes, all of that's really true.
Hmm.
And I think what's also true is I think we were talking about this a little bit before, right? But our company and our cohort of companies, our peers in the space, I think they've also learned from the past a little bit, like
Hmm.
about what's good and what's not good. I'll give you some examples, right?
Definitely.
Like, and these are like more practical, like like how do you build a robotic something? I think there's some practical lessons, right?
Hmm.
So like one is off the shelf hardware. It's really good. I mean, there's many reasons we talked about it.
Hmm.
Robotics as a service. I think what's really nice about robotics as a service is like you know, you don't have to convince somebody to put down $500,000, $1 million. I mean, that's really powerful. Now, by the way, there's caveats to that. Some customers, especially in industrial settings, they just want to buy the thing. So it's not perfect there, but generally it's nicer not to have to put down this big expenditure for a startup that you've never heard of, right? Which is
Definitely.
the case in selling like us, like most people haven't heard of Chef yet in our customer base. Another idea that like I think people are realizing is like don't try to automate the full process. And what I mean by that is if you try to automate the full
It's too
process,
much.
it's too much. You have to deal with all these things. Ideally, you have this little cell that can just slide on.
Yep. Totally agree.
No retrofitting.
Yep.
There's all these lessons. Another one that's interesting that's like less technical, but like, for a while people used to like fund inventory for their hardware using
Yeah.
equity, right? And now I think the world is realizing that it's a real hard asset. Like
Yep.
I don't need to get equity. I can just get debt, right? And that's really nice to actually finance the inventory to actually do these robotics as a service deployments.
Interesting. I don't fully understand that. Would you tell me a bit more?
So okay, so here's the way you can think about it. It's like, okay, like I sign a customer, right? Our business model is robotics as a service,
Yep.
right? So, we have to buy the bill of materials up front. So we have to like outlay all this cash up front, but we don't get paid
For a while.
all at once, right? Exactly. We get paid in bits
Yep.
and pieces as a service. So now there's a big cash flow issue, right? So like if I have like, let's say I raised 10 million bucks as a seed round, and I want to deploy 10 robots. I don't know. Like, I'm just saying arbitrary bomb.
Yeah,
but
for
like,
sure.
You get the point. Like I have to I've already spent a bunch of my cash on inventory. Well, wouldn't it be nice if that 10 million bucks is really for keeping the lights on, hiring engineers, hiring deployments folks, applications
Actual
engineers, et
operating
cetera?
expenses. Yeah.
That's right. And then I get some equipment financing, and the way that might work is like, I sign a customer, I take that contract to the bank advances me cash.
Yep.
I use that cash to buy the inventory. I provision the hardware with my software.
I like it.
I configure it, and then I deploy it.
Yep.
I pass site acceptance test. The customer starts paying me, and then I
you
start
pay
paying the
lump.
bank.
Yep. I
And
like
so
it.
what this means is that the cash flow cycle is much better because I have like instead of like waiting X months to return the
Yep.
the cash of my bill of materials, I can be net cash flow positive on the unit basis in a few months.
Yeah. And you don't have to trade equity, which is way better
Yes.
because you can incentivize
Yes.
employees, you can keep more for yourself,
right.
you don't have to raise more
right.
rounds of investment than you need.
Yes,
Um,
and you can
big
grow the company.
wins.
Like, I mean, yeah, and all of that. And remember what you said earlier, which is like in robotics, you have to continue growing gradually,
Yep.
right? You have to show like the Tesla analogy. Well, if you have more equity, you have more runway, which means you can ship more
Definitely.
robots. You can show more progress, which then allows you to raise more capital and
Even
the flywheel
better. Yeah,
continues
you're
again.
right. You're right. That is great. Let's see. So I know you wanted to talk about a few things, and we are coming to the end of our time. But why are many robotics companies failing? Like, what have we learned?
Yeah, I think like like I said, I tried to really study the industry early on when thinking about Chef because I was just like it was like okay, what's the biggest thing I could possibly? I was like, what are the big things I could work on? And I was like, energy seems really big because like obviously like there's a big climate change issue and like energy's really kind of like
And we're
one of
building
the
our
key-
industrial plant. Like, we
Yes.
need way more, probably 3 times or
We need way
something
more
crazy.
energy.
Okay. Yeah.
Yes, and then it was like AI, and within AI, I was like AI in the physical world, and I was like so convinced that this is such a powerful thing. Like I
100%.
think AI in the physical world is really going to be like electricity, right? So I was super excited, but then I look at the industry, and it's a graveyard. I mean, it's like robotics has been tough. Honestly, that's just the truth, right?
Yeah.
There has been like a lot of failures.
Definitely.
I mean, the AV industry has sucked in tens of billions of dollars, and yet the output has been millions of dollars in revenue.
Yeah.
Right, like single digit millions, probably.
Yeah, it's
right?
true.
So, anyways, I really tried to like learn from the industry. I think one big thing I learned. I mean, there's a bunch of lessons which we could talk about, like dozens probably. But like one like thing that I think kind of puts a story to life is like I think a lot of people who do robotics, the founders, right? They're extremely technically minded folks, right? They're very smart folks because and very usually generalists because it's such a breathful field. Like
Definitely.
you need somebody who kind of like can like at least understand everything from like computer science and AI to then of course the electrical stuff to the mechanical stuff to everything in between firmware manufacturing, etc. Even service and customer success. Like there's a lot of facets to it. So what does that mean? What that means is that there's a lot of folks who just like to build cool stuff, right? Like it's like robots are cool to build. And I think you saw a lot of the robotics companies who were like in previous generations who were like, you could tell it's just like, hey, somebody's like, let me build something cool. Um,
Definitely.
and and I think, you know, that can work, right? And it has worked in the past in other industries. But the issue is that the iteration loops in robotics are much slower than something like software.
Hmm.
So here's what I mean by that. Like, if I'm a software as a service company, right, or I'm a consumer software company, I can build a prototype in a weekend,
Hmm.
right? You know,
Yeah, well,
I can
pretty
get
quick.
something working. It's a
For sure.
hackathon style, right? Like
Yeah,
MVP, I can get up in 24 hours, 48
totally.
hours, whatever. Might not be perfect, but you get the idea.
Yeah. Your
And then I
Pareto,
can very
that's your,
quickly,
you get
yes,
80% with 20% of the effort or something like this.
that's
Okay.
right. That's right. And then you can iterate, right? And this is the entire Eric Ries startup, the lean startup model, right? Which is like you kind of have a hypothesis, you kind of like build a prototype, and you iterate till you get to product market fit.
Hmm.
And I think Silicon Valley, a lot of Silicon Valley, I mean, modern Silicon Valley, like software, not the old semiconductor Silicon Valley, is built on that idea.
Hmm.
Um, if I'm doing robotics or autonomy or AI more generally, the iteration loops are just fundamentally slower. Even if it's like autonomy is slow because it's like hard. Like autonomy is much harder
Definitely.
than making a web app, right? Um, so, and that's just the truth. It's not like you need both,
Yeah.
right?
No, I
You need
agree.
both,
For
but it
sure.
just, um, but the iteration loops are slower. So like instead of having 10 shots on goal with a pre-seed round or the seed round, you have one shot on goal before you run out of money, or maybe you have two shots on goal. So this idea of let me just build a cool thing and then I'll iterate, it doesn't really work because you end up building the wrong thing and then you fail.
Hmm.
I mean, and I've seen this over and over and over.
Me
Like
too.
founders build a cool thing and then you end up not being able to raise the next round,
Hmm.
basically. I think now what a lot more companies are doing in our cohort, right, the more kind of contemporary robotics companies is you still need the same technically minded founders, but
Got to be
I
market
think people are a
focused.
little bit more business focused.
Hmm.
Um, so it's things like okay, like for example, we sold the product before we built it. Like when we were doing fast casuals, even like we got contracts, really making sure that people really want this thing,
Hmm.
right? Like we know for a fact people want this thing, and of course we reduced the risk for the customer too. We added a site acceptance test that said, look, you're not actually going to pay the recurring fee until the thing works.
Hmm.
So we reduced risk for the customers, but we knew that they wanted it.
Hmm.
Um, for example. But what selling before building got us is like we know they want it. We have a good product requirements document where we've synthesized all the requirements from multiple customers, so we know we're not overfitting on any particular customer.
Hmm.
So I think what that allowed us to do is we didn't have to iterate towards product market fit. We kind of like had product market fit, if you will, from the get go. Now, obviously, there's still lessons. There's still unknown unknowns and even
Definitely.
known unknowns. So there's still lessons, but you're less likely. Like we were able to really get product market fit in like one iteration loop, which is fast casual, and the second iteration loop was food manufacturing,
Hmm.
as opposed to like 7 or 8 iteration loops, which is really where you end up not working, I think.
Definitely.
That's one lesson I would say that's really been interesting, which is selling before building and kind of coming at it from like, are we really solving a customer pain point?
Yeah.
As opposed to just trying to build something cool.
Totally. So selling before building, I hear the idea a lot for SaaS projects now, at least on X and things like this. How do you get a customer to sign off that is it like a contract that they will pay once you deliver something, or how do you sell before you build? What does that look like?
Yeah. I think, yeah. So I think where this starts is you have to get them to realize that they have a really big pain point and tell you.
Hmm.
So this isn't like you go to them and say, like, I'm going to build, like, it's not really a sale, right? It's like really them selling you
It's a
almost, right?
commitment,
Like you go, well,
or
well,
no?
no. I guess what I'm saying is like you go to them and you're like, okay, customer, like, what's your biggest pain point? And this is literally what we did. It's just interviewing them almost,
Yeah.
right? Um, what's your biggest pain point? They say food assembly. Then they're like, okay, well, can robots help? Yeah. And like then it's like, okay, well, if we were to do this, would this be something you pay for? Yeah. So in other words, they're kind of selling you like it's kind of like how big of a problem is it for them is I
Hmm.
guess is what I'm saying, right? Like if it's a really big problem for them, and there's no solutions in the market, right? Which is what was the case in our case.
Yep.
Then they're going to be a lot more willing to work with you.
Hmm.
So what we did is we went to them and said, look, customer, we know what your requirements are, and here they are. We've written them into this Word document. Like, do you agree that these are indeed your technical requirements?
By the
Yep,
way,
they
we're
agree.
we're at our ending time. Are you okay to go for another maybe like 5-10 minutes, or do you have a hard
Yeah.
cutoff? Okay, hell yeah.
Yeah.
Sorry to interrupt.
No, good. So, here's your technical requirements, and do you agree with those? Yeah. And then we say, okay, well, look, like we've done this financial analysis, and we think that if we were to charge you X dollars per year, this would be a financial win for you, and here's why we think that.
Mm-hmm.
Do you agree with that? Like, assuming these assumptions are indeed true,
Mm-hmm.
yeah, we agree with that. Okay, well, how about this? Let's work together and sign this contract that says if we build this thing,
You'll buy for this.
um, and it meets this site acceptance test. This is the key part, the site acceptance test.
Ah,
It meets this set of requirements, and these set of requirements will be things like: is this consistent? Is this fast? Is this footprint? It is this food safety rating, et cetera, et cetera. It can do this wash down for sanitation.
mm-hmm.
If it meets these requirements, then you will pay us contractually this amount of money. And just to make sure you're really serious, how about you put down XK as a deposit? And it's not a
Ah,
non-recurring engineering, but it's just a deposit to really make sure you're serious.
okay.
What this is, it is a true contractual agreement, but the customer hasn't outlaid a ton of cash, but they have put their commitment down that they're
Yep.
serious about this.
I love it. That's great. What a cool idea to, because I've been seeing this in SaaS where people are like, don't build it first. But seeing it in robotics where it's a hardware project is a new idea to me, and it's really cool.
By the way,
Yeah.
I actually don't think it's as new as I thought this was new too.
Yeah.
But then I learned that like a lot of industries work this way.
Yeah.
So like a systems integrator doesn't like I was talking about the Heinz line, right, for making ketchup.
Yep.
Some like JR Automation or JMP Automation is not putting up 10 million bucks of their own capital and going to Heinz and being like, hey, do you like this thing? Okay, we iterate a little bit. Do you like it now? Oh, we changed a little bit. Okay, do you like it now? They don't do that,
Yeah.
right? Instead, Heinz goes to JR Automation, and Heinz said, "Hey, here's what we need to build," and JR will put together a quote, right? And then like Heinz can sign off, and that's when
That's the ticket.
JR Automation starts to work.
Yep.
There's a lot of examples also about this. I mean, like, generally, like I think like if I'm like Boeing, right, like, and I am like Delta, I just made that up, but like,
Yeah.
Boeing is not going to make Delta some planes without having a PO. And by the way, that also goes for new models. So like there's an interesting like story with like Pan Am Airlines and Juan Trippe. Juan Trippe is like the guy who like made Pan Am. And he was negotiating, I think, with the CEO of Boeing or something at the time for he wanted like a really big jet, and basically the Boeing CEO was like, look, if you Pan Am give me an order for X planes, then I will build a 747 for you. And so Pan Am put down a commitment. Okay, Boeing, so long as you meet these commitments, these agreements, these requirements,
Yep.
I, Pan Am Airlines, will buy X of your 747s. So now the Boeing CEO has commitment
Yep.
that people want his plane. And now he's willing to spend billions of dollars of R&D into making this 747, which is kind of how the 747 started.
Cool.
I think there's a lot of examples actually where the selling for before building. I mean, Bill Gates did this with MS-DOS. He sold MS-DOS to IBM before he spent time and money. He didn't drop out of Harvard. He sold MS-DOS to IBM,
Huh.
and then he built MS-DOS, or Wozniak. or, sorry, Paul Allen did. But yeah, you get the point.
Gotcha. Yeah, I bet you're right that it's more common. I just haven't seen it in a robotics context, at least that I've noticed, which is quite cool. Okay, hell yeah. And then a last thing that I wanted to talk about is why is production hard?
Yeah, this was an interesting lesson for me, right? Like, I think like robotics is already extremely hard as it is, right?
Definitely.
It's just like so hard to just get 0 to 1. I mean, it takes like it can take a year, 2 years to get even 0 to 1, right? And autonomous vehicles took 10, 20 years to get from 0 to 1.
Mm-hmm.
But then production is just like at least 10 to 100x harder, right? And what I mean by that is like the amount of edge cases are just insane. So I'll give you an interesting example. Like food facilities are sloped, and the reason they're sloped is for water drainage.
Yeah, it makes sense.
Now, by the way, we just talked about selling before building. We talked about getting product requirements early. Like I'm all about like the product part early, just to really understand the requirements. But even I did not notice that the floor is sloped, right? Like it's just imperceptible. And it's not even a question you know to ask. You just don't even think about asking it,
Yeah.
right? So we shipped our robots to production, and the very first thing we noticed is the robot's like, shaking around. This is like day one. Like we shipped a robot to production. It's like, oh damn, like what's happening here? Like
Why is
we
this
this
happening?
wasn't
Yeah.
showing up. Why is this happening? And then of course we asked them, and they're like, oh, that's what's happening. So anyways, that's a hardware thing. Okay, let's add stabilizing feet. But then it's also like, then the next thing we notice is, okay, well, the robot's like this. The conveyor might be slanted. Okay, well, so now if I have to like detect the slope of the conveyor and place lower or higher.
Uh-huh.
Okay, now it's solved. Great, we solved that issue. But then like now instead of day one, now we're at day now we've run for 16 hours a day. And after 16 hours of the conveyor running, the conveyor is shaking. It's like vibrating a lot too. So now the conveyor, it's already like this, but now it's like it walked. It's a little bit, it's like this, it's scheming. So now you have to place lower and closer and farther and higher.
Yep.
Again, this is just a very simple example. Now we deploy with our next customer, and that next customer has cheese grits. And every single day, those cheese grits are totally different. That's just what it is.
Yep.
And then, at a different customer, you have humans who are kind of like eager to go home, and they're like, they're randomly taking bowls out of, like, they pull the bowl from in front of the robot. And so the robot has detected the bowl, it's tracking the bowl, and now the bowl disappears. That track is like, what, I don't know what to do. Like, what's happened? There's all these weird things that happen with different ingredients, like other humans that you're interacting with, detecting the velocity of a conveyor. You think it's simple, monotonic, right? It's like probably simple to use a camera to detect the velocity of a conveyor. It's super noisy. It's like it's all over the place, and every conveyor is a little bit different. So how do you have really good speed estimation of the conveyor so you can actually place onto a moving conveyor and get in these very small compartments? It's actually not trivial. So I think there's just a lot of like, and I can name hundreds of examples like this.
Yeah.
Like, there's just so many like weird things you just never even think about.
Totally.
And so like that's honestly like, when you think about like a moat, I think the data moat's really good, and I think the service moat, like actually having this like network of people all over the country, but like from a product perspective, just dealing with all these edge cases, like even if you copy my hardware, even if you copy my software, like dealing with all these edge cases and making a solution is pretty hard. I'll give you one more example, final example, like usability, right? Many of our users, the people actually on the line who are like telling Chef what to do, they're often not English speaking. They're often Spanish speaking or Farsi, or they speak different languages. And they're often not necessarily college educated or even high school educated. So we need to make a system that's like hundreds of thousands of lines of Python and C++ code and all this like cool hardware be used by somebody who hasn't really dealt with machinery or robots or software really ever. So the usability is actually a lot more important than you might think. Like actually having everything in Spanish, or being whatever language that is most prevalent at that site.
Yep.
Having the system so it's extraordinarily obvious that this is the thing to do. Like if something, like if a bowl is too far on the conveyor so the robot can't reach, throwing a really nice visual 3D warning, oh, the bowl's too far. Or maybe somebody comes up in the morning and they're like, I want to go home, so they crank up the conveyor speed. So the conveyor speed is way faster than the
Expected,
ODD
spec
or like
one.
the
Yeah.
expected speed. Yeah. And now the robot's like, I can't keep up with all this. And now the user's really upset because they're missing bowls, missing containers, but the robot can't do anything. So throwing a nice warning, you're on the dashboard, oh, your conveyor's moving a lot faster than it should. But doing that in a way that's not in words, but rather in images.
Something easy to explain. Yeah. Images.
I mean, these are just some examples, but there's so much stuff that really separates like a prototype company from a production company. And
For
then
sure.
going from like zero robots to one robot in production is a big deal, and then 10, and then it's just like every layer. It's just like the amount of volume of stuff going on is just absurd. Like,
Oh, yeah.
now we made 17.7 million servings meals in production.
Congrats.
It's just the amount of stuff happening is just a lot.
Yes.
And you have to have the right data infrastructure to be able to process all this, alert the right people, annotate all of this so you can actually triage it, all this
You
stuff.
got to keep up with it. Do you have any?
You got to keep up with that.
Do you have any heuristics or like lessons or any things that would have, like any mindsets or anything that would have made this whole process of dealing with all these difficult edge cases that pop up in production a little easier, or just be ready for them and steel yourself for it? Or what do you think? Like anything would have helped you
Yeah,
in preparing for all
I
this?
think, I mean, there's a few like strategic things and a few practical kind of tactical things that come to mind. I think like the thought that's coming to my mind is just like we really think a lot about hiring and like hiring really good people, but just honestly, just continue hiring the absolute best people. If you have a really, 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 really good team,
Mm-hmm.
they can knock this out, right?
Yeah.
Um, I think it just starts with that, your team, right? And then also having yeah, like it seems like kind of like not. I mean, on the surface, you might be looking for like a very tactical thing, but like having a culture where everyone really, really cares about the customer, right? I think there's a
Oh,
lot of companies who like they talk about customer centricity, but they really don't care that much about the customer.
yeah.
Whereas like if you can build a culture where like like everyone across the company just knows everything that's happening with the customer. They've been to the customer. They know the customer. They know why the customer cares about something. Then like if there's a little bug that happens, people can empathize. It's
Yep.
like my code is doing that. I need to go fix it. And
Mm-hmm.
there's like a personal if that means I'm going to stay till 8 fixing this bug, great, because I care about this customer and
Mm-hmm.
like I know how impactful this is for the customer. So
Yeah.
I think that's some like strategic stuff. On a practical level, I think like I would say a couple of things. Like really, we invested a decent bit in test infrastructure and like data pipelines. I think we could have done even more, right? Just like really
Mm.
good internal tooling around data infra. So like even better tagging, even better annotation, even better processes so that like, if there's like creating federations, so there's like 20 um, high weight events. Let's like aggregate all those into one bug ticket so that we have 20 bag files so that when an engineer goes and triages them, they have all the data they need right there,
Mm-hmm.
right? Or another example might be like, okay, well, um, if I patch a PR to fix something, let me automatically patch it to like every branch that we have in production. I mean, these are
Hmm.
like not, these are commonly,
Yeah.
these are software tools that, you see in SaaS all the time and like production companies all the time, but
Setting them
robotics
up.
doesn't have a ton of them.
I agree. Mm-hmm. Yeah. So really investing in that tooling because that improves process. And every time when you have a crappy process, it eats future time
Yeah.
because you have to go do whatever it is.
By the way, it's tough though. Like I'm saying this.
But you don't want to optimize too much is the other side of that evil.
Well, and like I mean, once you like when you're trying to do 0 to 1, I mean, you're not thinking about tooling. You just want to ship the thing, right? It's like
Yep.
whatever it takes to ship the thing out the door.
Mm-hmm.
And then as soon as you ship it, you're delusion. I mean, you're like underwater with like bugs. You're
Yep.
diluted with like, or yeah, like so you know, and then you're like, there's a lot of pressure to grow, and so anyways, like it feels it's like you want to do this internal tooling stuff,
Mm-hmm.
but it's like how do you create the time to do it, right? Like there's always this like hard battle.
Yeah.
You need to do it. It's necessary, or else you're never gonna get ahead of it.
Mm-hmm. Yeah. I feel like I don't know. For maybe I guess it probably comes back to the people you hire to some level for this kind of thing.
Yeah.
Because like one of the joys that I've had working on the ROS 2 project is have wrote a lot of tools and a lot of scripts to automate really dull things for us. Because one, I like doing that, and two, they make everything else easier. And when you have more
Yeah.
consistency across projects, it's much easier to write additional future automations. And
Yeah.
so, like having people that want to go out and do these kinds of things and know about them, that there is the option to do this thing and improve the process, that might be a good way too.
Yes. Yes. No, I totally agree.
Hell yeah. Yeah, hiring, as you said.
Hiring is everything. Like, some of our engineers will just like, they're like, okay, I need to solve this thing.
Yep.
And if I can spend another half an hour, I can build this quick little internal tool.
Yep.
And like, it's not like a part of the sprint. They're just like, I need to do this because it's going to help me. And I really care about the company and I have a lot of equity in this company. So let me just do it.
Yeah.
Right.
Totally.
And by the way, I say that by the way, because it's an important point, which is like, it's like if you hire people where it's not just a job, but like it's really like they really really believe in it.
Yeah.
Like if in other words, you kind of treat your people like investors. They're like investing into their company with their time.
Yeah.
They really believe in it, and so if they really believe in it and they have a lot of skin in the game, then it's less, it's not like, okay, I just gonna do my sprint, I'm gonna go home, right? It's like I want to make the product and the company and the machine being the company better.
Yeah, it's mission oriented, trying to help the
Yes.
whole thing. Yeah. Do you have
Yes.
any thoughts on how to hire good people, or how do you find good people?
Yeah, that's very tough. Hiring is actually a lot. I mean, like people think like fundraising is hard. I mean, I hiring is extremely tough, I think,
Hmm.
honestly. I have a few thoughts. Um, One thought I have is that, I watched this like famous, I don't know if it's famous or not, but this clip by Derek Sivers. He talks about basically, he's the guy who made CD Baby back in the day. And like, he
Okay.
had this famous clip, this like quip, which is like, um, the first follower is the person who turns a lone nut into a leader. So he kind of shows this like little clip
I love that.
of like somebody like dancing around the middle of a field, right?
Yep.
Just randomly. And he was like, "Oh, who's this weird person?" And then one other person joins. And as soon as that one other person joins, everybody else comes.
That's
Um,
hilarious. I love that. Yeah, you're like an eccentric doing your
that's
thing until others follow you, and then you're
yes,
the leader.
yes,
Hilarious.
exactly. And I think that's how hiring works. So when I try to find like my approach was always to get like very senior folks. Like I want senior staff level engineers
Yeah.
from the get go, which by the way was hard because like we're this tiny company. We
Yeah.
can't pay a ton of money in terms of salary, right?
Hmm.
At the time, right? This was like back in 2019,
Yep.
2020. Um, so it's like, how do we convince somebody? So like initially it was just a lot of rejection. We talked to a lot of people, and a lot of people are like, "Look, this is great, but I have a mortgage or I have a partner, and like I have kids, and sorry."
Hmm.
Um, but we ultimately convinced one person who had a really, really great set of experiences, quite senior, had been at a bunch of top companies, had
Hmm.
been a lead, and like brand names that people know of, right?
Yeah.
Like respectable, basically.
Hell yeah.
Getting him was huge because as soon as we got him,
Others
when I
follow.
talked to the next engineer, I wasn't the one selling that next engineer. This person was the one that's selling the next engineer,
Ah, hell yeah.
right?
That's so funny.
Um,
It's a lot like that podcasting, by the way, which is very funny.
oh, really?
Getting guests and
Interesting.
this kind of thing. Same
Ah,
dynamic.
interesting. Cool.
Okay.
I think that's honestly the biggest thing, just like having a high bar early on. I think it's in the
Huh.
early days, it's easier just to like take whoever because like you don't have much to offer. So it's like come anyone who's willing to come. But I think if you have a really high bar early on, then you set yourself up in many ways because this thing we just talked about from the hiring perspective, but a really good engineer has good architecture decisions
Hmm.
because
And
like
that makes
it's like the
everything
famous thing
better.
like
Hmm.
yeah, like Facebook still uses a lot of PHP. It's like why do they use PHP? Well, it's because originally Facebook was written in PHP, so it persists. There's inertia there, and I think that's true of like technical decisions. Like for example, if you start off with ROS one, it's really hard to do ROS two.
Hmm.
But if you have somebody who is who's been around the block, they might recommend ROS two from the get go. That's a
Hmm.
good architecture decision and probably going to pay off in the long run.
Hell yeah.
Um, but you know what I mean, right? Like there's many reasons to get a more senior person from the early days. It's harder, but if you can do that, then it makes hiring other people easier. And then after that, just keeping a really high bar,
Yeah.
having a really good interview process. Um, yeah,
Hell yeah. I
it's
like
not
that.
easy, honestly. Like I think
No.
interviewing is really hard.
Yeah, I think so too. And I love that lone nut idea.
Yeah.
Hilarious. But so we have gone quite a bit over time. I am wondering if you have any last thoughts or things you'd like to share with our audience. What do you hope they take away from this interview and about Chef Robotics?
Yeah. I think I'll say on a more broad scale scope, like broad scope thing, which is like I really, really, really think the biggest impact for AI is going to be on the physical world in the labor market. And I think, by the way, like it's not like this is not like a dystopian like take your job thing. I really believe in a future of abundance where, you know, 50% of the economy is manual labor right now. Like what if robots were doing that? And by the way, there's been a lot of instances where like automation has created a lot, like every instance of automation has created more jobs than it's taken. So like
Hmm.
the Jethro Tull or the printing press, the computer, right, the steam engine, these created a lot more jobs than it took, but the jobs are better. And I really am a big fan of that. So I'm really optimistic and hope that a lot more people are going to take their AI skills, right? Like, let's take those skills you've developed in machine learning and AI, or even software engineering, and like really apply them to do embodied AI. Because I think like the really important problems of the world, they're not in bits. Like you can solve it, you can do a lot in bits. You can do a lot in bits, right? Like Palantir is a cool example of a company doing a lot in bits. Uber is a cool company. It's moving atoms with bits. But I think like really the most important problems in the world are physical world problems. That you can't solve the global hunger crisis or water pollution or climate change using just software. You just cannot. And I really hope that more people take those skills and apply them to the physical world. I think that'll be really good for humanity in the world. Um, and then when it comes to chef, I think like, I think like we have tried to stay very grounded. Like let's have a big vision and mission, but like stay very grounded and actually shipping real robots that really help solve an actual pain point for the customer. I think I think that's really key in robotics. I think it's so hard to do robotics as it is, but if you have a customer or ideally a set of customers who's telling you what to do, and of course you be careful not to overfit, then you can really build something that's actually useful. And hope for, if you have the right vision, then something that can become quite scalable. And I think, if that's exciting for you, then of course we'd love to chat as well.
Hell yeah. All right. It was a pleasure. And, well, bye, everyone.
Thanks for having me, Audrow.
As we wrap up this fascinating conversation with Rajat Bhageria, I hope you're as excited as I am about the potential of AI and robotics in the food industry. Rajat's insights into the challenges and opportunities in this space are truly eye-opening. Before we go, I'd like to leave you with a question to ponder. How might AI-powered food automation reshape not just the food industry, but our entire relationship with food production and consumption? Will we see a future where customized restaurant quality meals are as accessible and affordable as fast food is today? If you found value in today's discussion, I'd be incredibly grateful if you leave a rating or review. Your feedback not only helps others discover the show, but also helps me to improve and bring you the content you want to hear. Thank you for listening, and until next time, keep exploring the fascinating world of robotics and AI.